Hello everyone, and welcome to my stream today. How's everyone doing today? Come say hi. Been a little while. I think it's been like 3 weeks since we've done a stream. Just doing green smoothie today. Shaking it up a little bit. I'm excited because we're going to talk about reactivity in signals, which to no one's surprise is one of my favorite topics. Hello. I've been busy. Admittedly, sorry, my mic cut out there. Admittedly, a lot of how should I put it? Exploration into reactive stuff's been really on my mind. I apologize to all you solid start users out there who are probably like, when's the new Nitro release gonna get in there? You know. Hey Brandon, how's it going? Yeah, nice to see everyone. Hair check. I don't know, my hair's just like sticking up in the back right now. Yeah. I've been cooking. Yeah, that's one way. Cool. Yeah. I ever heard about signals? I have not, I have to admit. This is kind of one of those interesting things. Not in that interesting, but like I went back more to learn about the academic aspects of signals. I was just you know the thing was like you learn the framework and then you learn the fundamentals kind of thing. I was just a knockout user, 14 years ago. I mean, when I started using knockout, even though I'd been like a web developer for almost, I guess technically over a decade at that point, I admit I did not know JavaScript very well. I I mean, to be fair, web development in the late 90s, yeah, that I did JavaScript a bit then, but then like through the 2000s, I wasn't writing in JavaScript. I was writing in C Sharp, .NET kind of stuff. So, and Ruby on Rails, a little bit of PHP. So like, but yeah, I mean, in 2010, JavaScript had already kind of taken off, and I admittedly didn't know very much. I learned it on the go. I learned Knockout, which made me very excited. And most of my everything I've learned since has come back after that. Okay. Yeah, and that's been I used to read stuff by Andre Staltz, createSignal.js, and the way he described, obviously he was talking a lot about RX style streams, which he said was not like standard FRP, but even what they described as standard FRP didn't really quite fit with what I was doing with signals. I think if I read it now, I'd have a much better understanding and much better like perspective, let's say, on like how these pieces fit together and what the similarities are. But I started from a very narrow place, basically Knockout JS, and then kind of expanded out there. I just had a lot of time. It's been like 14 years since I first used Knockout JS. It's like instead of signals, you had event emitters, and you composed all signals out of RX operators. See, the funny thing is when I looked at Andre's work, he suggested that event streams weren't necessarily FRP. Like there was a big debate back then in like the 2016 time period where everyone was like saying that like there's a difference between FRP like as like stated in academics and then like what RxJS was doing. But I don't know. I don't even know. How would 2014 Ryan react to Solid? Um, I mean, 2014, so like 10 years ago, he would have been pretty excited, although he would have been like, I'm not sure about this JSX thing. I was not a fan of JSX. So yeah, I think 2014 me would have really liked um modern Vue. I think like Vue plus the composition API. Like 2014 me did not like Vue that was there, but if Vue looked like it does today back then, I think I'm that's probably where I would have been. I would have been very excited about like Vue 3. Um yeah. Did I vote? I am a Canadian living in the US, so I did not vote. I can't vote. Do you mean I love Svelte? I don't know. Like I I might have liked Svelte 5 a bit, but I think yeah, I don't know. Given where I was at, I actually think Vue 3 would have been where my head was at. It's funny given what I know now. But yeah, like I think Svelte 3 and 4 would have turned me off even back then. Svelte 5 would have been interesting, but I mean it's hard to picture. Yeah, yeah, I don't know. I used to like Ember a lot, so like the handlebar syntax of Svelte's templating would have been really attractive, but I'm not sure if I would have liked the ruins or sorry, runes. I can't freaking say that. Um, yeah, hard to say. I'm like trying to think of like 10-year-old me. Yeah, I'm sorry. Runes, like that's failed attempt. Like was it from Microsoft that had like was it Sound Machine? It was no, I guess that Zoom Zune Rune. Anyway, what I'm not doing this again. My friend said Rune. My friend Rune says my friend Rune said runes rune felt. Okay. That's like a tongue twister for me. I can read, mile a minute on Dr. Seuss, Fox and Socks and oh say can you say, but can't say that sentence. Zune. Yeah. Yeah. Thank you all. Yeah, okay, okay. Let's see here. Yeah, okay, so that is my only browser. Give me a second here. I actually have to like open some stuff here in the background while I actually get set up to share my screen. Um, so let me see here. Fox and Socks. Yeah, great book. But what we're here to talk about today um, is a lot about signals and the future of signals. And it's kind of funny because, yeah, I don't know. Do I even want to dive into it yet? I just give me like a second because I'm still prepping. What can I talk about while I'm getting stuff ready here? What I've been up to. I went to NextConf. That was interesting. I mean, I think the biggest takeaway for me personally from NextConf is I feel less worried about. Yeah, I don't know. I feel I used to like get really worked up about whatever React was working on and be like, oh no, how does this fit into my mental model of the world? And I feel like after leaving NextConf, for once, I actually just don't care what React's doing. I think the cache API is so much better now. Like just like worlds better. Like, whether to use cache or a wrapper or whatever, I don't care about that detail too much. There's a reason to use cache, and we talked about it a couple streams ago, or like last stream, like 3 weeks ago. But like, just getting into a world where explicit is as ergonomic as all that auto magic is just huge. But like, I don't know. It's just funny. I was watching some of Theo's stream, and I think can I get my screen share working here? Share screen, entire screen. Yeah, here we go. So this still works. And I think he had a tweet or something here. Yeah, he put this thing up, you know. And I was looking at this and I was like, I get what this is doing, but I wonder if many people actually get what this is doing. Like, it's kind of cool when it's funny when you're writing frameworks, you're always in the event queue. You're always trying to do. There's always ways you can like warp JavaScript. This is like one of the reasons I actually love JavaScript, is because you can kind of like, you have so many places to like get into it that you can do some pretty cool stuff. Well, I think the thing is not exactly. I think most people look at this and they're like, oh, set immediate. First of all, I got a question for you guys. Do you guys know what set immediate is? Right. Sorry, this is a little tangent. We'll get into the really cool signal stuff shortly, but I just wanted to just talk about this for a minute. The idea here is that they were trying to come up with a way so that they could detect on a render pass, the parts that are static or dynamic, right? But yes, it creates a macro task, not a micro task, a macro task. Because some of you might be thinking, why didn't you just like queue, what was like queue micro task or go promise.resolve or something here? Why are they using set immediate? Set immediate is just set timeout. It's a fast set timeout. It's a set timeout that goes in the front of the list, but it's not yes, it's faster than set timeout 0. That's essentially what it is. And in the browser or environments that don't have set immediate, we actually do tricks like this. There's like post message on the Windows object, which lets you also do this kind of thing without set immediate. There's a few hacks. Almost most framework authors are actually very familiar with these kind of hacks around scheduling, because quite often the problem is microtask queue is a queue that just keeps on feeding into itself. And at a certain point, you have to let it just like flush out and then get control. The problem here, and the reason that these kind of solutions, like as it's a whole category of solutions, but after watching, a lot of people were looking at this and it's like, I get it. They render the sync render and then they go and then they call the abort controller, and then this will cancel it out, right? Before any of the async stuff runs. But it's not exactly true. This sets up a macro task, but the reason is not because you don't want the microtask queue to run. It's not because you're preventing this. It's that, I mean, check it out. I mean, I'm just trying to think if I should, like, how much I should show on this, but if I write a function that's like an async function like this, let's say like hello, right? And I go return 5. if I go console.log hello, what do I see? I mean, I just spoiled it. It's in the freaking corner. I see a promise. Like, as soon as you go into this zone, it's a promise. It doesn't matter if it can resolve immediately, it's a promise. So you have this interesting thing where with promises, they can basically queue other promises that can queue other promises. Like the whole callback stack, I don't know if you've ever seen like a promise when you go promise then, and then you like return a promise. You know, like a classic example, this is like when you're doing like fetch, right? So like you might do something like function fetch user whatever, and then you do a you first await sorry, I gotta make this async, but I guess this is more prominent when you weren't using await syntax, but let's say you did like a fetch call of some sort, right? And then you get the results, and then you go like, you can just return JSON here, even though this technically, or sorry, res.json, even though this technically is a promise, promises like chain like that, essentially. Like if they see a promise of the return value, they'll automatically, you know, the thing listening to fetch user will automatically do that. You don't have to await this, is what I'm getting at. And it's similar characteristic to this where it's always a promise regardless. So what this means is, at least the way I took this code is, they actually want the micro task queue to empty out. What they're trying to do is they call the first set immediate so that they're like, okay, make sure like the current macro task is out of the way. You know, whatever's currently synchronously going, just let it go. Okay, all the micro tasks that are currently queued, whatever's going on, just let it go. Okay, and they immediately queue on these two right after each other, which means they should be running in quick succession on macro tasks. But between these two, the microtask queue can still run. They've just set it that these two are right next to each other. There's like nothing in between them. And this means that microtasks, you know, like silly things that can resolve immediately, like an already imported code split that has already been imported or whatever, or like a synchronous return value inside an async function, can all resolve synchronous, like not synchronously, but before these things actually complete out. That, at least that's how I take it. Maybe I'm wrong. Maybe I didn't watch the talk or whatever. I think I actually missed this one. I was outside at the time, but like mechanically, when I see that, that's what I'm seeing here. This is an example of a kind of framework trickery. Sometimes we play around similar with stuff like animation frames to make sure that we can get enough work in before the paint, but sometimes you want something to render after paint. Well, how do you tell something to render after paint, right? Request animation frame is before paint. So you actually need to request an animation frame and then inside it do a set immediate. Like basically you want the next macro task after the animation frame. So this is a whole category of scheduling kind of optimizations. Anyways, it's funny because while this wasn't a solution I looked at using an abort controller, which is kind of clever here because it'll cancel the stream, our single flight mutations actually have to do the same kind of thing, right? Because we have to basically, we don't cancel all of them, but we're going to run over a bunch of cache functions and promises that some of them have to respond, other ones we'll recognize as not needing to be refetched, and we basically have to cancel out. It's also similar to a trick that we've been using on client-side hydration with createAsync, because we need to kind of run the function to get the reactive dependencies, but we don't actually want to run the promise again on the client. We want the server serialized data to just show up. So yeah, it's kind of interesting what goes into solving these problems. But then you remember the whole reason that you're solving this problem is because of the architecture they're using React server components, something that honestly I don't really care about. So actually, well, very cool. This actually doesn't actually have anything to do with anything that I am thinking about these days. But yeah, I know, long way to get around to that. If you're interested in these kind of mechanics, there's a lot of interesting little tricks you can do in the frameworks around the event queue. Very powerful thing. Everyone should learn more about it. This is where I'm supposed to have a link to tell you where to learn about it. All I know is that a video that I haven't seen apparently that Lydia Hall formerly from Vercel created about the event queue. So maybe someone could share that in chat. I heard that's a good source. Her work generally is very accurate, so probably a good place to look at. Anyways, how's chat doing? Post message is the fastest, yes. Yeah, sorry, I'm just catching up on chat. It's been like 7 minutes, sorry. You guys probably should have interrupted me. Can we avoid these set of medias by calling abort before pre-render? I don't know the timing of abort. Even if abort queues a micro task, it might be the timing might be wrong. Yeah, that's what I meant, probably. Might have got her last name wrong. Is it Holly? Okay. Anyway. Oh, cache API? I've been talking about the use cache API. We actually talked about this on stream last time. It's a very clever way of defining any function as cacheable, but the whole trick to it is it's a server function, essentially. So it becomes its own entry point, closes over the same variables. There's a whole bunch of stuff you can do about it. It's just one of those funny kind of things is when you come to the realization, I was like, okay, maybe I should use cache to Solid, or, should Tanner put it in TANStack? And then you're like, actually, you probably don't actually need, like, the reason that API is attractive is because of server components. If you don't have server components, you don't really care. So it's kind of, yeah, it was kind of interesting to be standing in a space where, rightfully so, a lot of people are really excited about this stuff. But then on the other hand, you're kind of like, it's good to solve the problems you created, right? So anyway, yeah, sorry, that was just a little tangent. We should probably talk about actual stuff. I mean, I can try and look it up. I don't even know. What was it? Task queue. Is that right? Here we go. This is probably the video I'm talking about. It's 12 minutes. So apparently, yeah, here we go. Let's just drop this in. Yeah, I mean, this is the one thing. Abort control is really powerful because you can like do stuff, but if we could cancel promises in a generic way, like there was this interesting discussion we had when designing create resource, because we have an abort control friendly fetch primitive, but I didn't bring it into solid core because I was like, I don't actually care. Like, okay, like there's a certain perspective, like once the promise is out there, like it's out there, like we can just ignore what happens when it comes back. Like the cancellation, it's too late. By the time we send the cancellation down the wire, the server's already hit the database. Like the whole thing is too late. But like, so I was like, what's the point of abort controller if literally we have race condition protection built into the primitive that calls it? But like, if promises just had the ability to do this natively, it'd be really interesting. On the other hand, would they be a promise? Right? The promise of a promise is that they like always resolve. Either they like, I mean, to be fair, you could always just not call resolve, but when you design with promise-based API, it's that like they're going to succeed or not succeed. So one of the things is like by API design, something like a callback isn't like guaranteed to call. It might call multiple times, might call once, might never call. Promises are designed in such a way that there's an expectation that you call resolve or reject. Like, don't get me wrong, some people or some code will not call resolve or reject, but via API, you are guided to do that. if they were cancelable, I don't know if that like changes the expectation. I guess canceled ones reject, so I guess that's fair. Yeah, yeah. I wish they were just cancelable. That might have been easier. I guess it's too hard and rough. Once can always start doing side effects even if you cancel it later. Yeah, yeah. It's I don't know. Some people ask me why I'm so stubborn about suspense being built around promises. It's just like it really aids people's like this then that, you know, so to speak, in terms of thinking an API design standpoint. To be fair, solid suspense could run completely off flipping signals. It's basically a counter, but there's something nice about. It's funny, sometimes when you work on APIs, you can't like pinpoint it, but you can kind of like get a feel for like how things guide you in a reasonable, responsible way. I don't know, that's the best way I can put it. Okay. Yeah, so we're talking reactivity again. I know we talked a bunch about it over the summer, but let's kind of get back up to date or up to speed with what the hell I'm talking about. Because a couple weeks ago, I think it was like October 23rd, I released this article. And I don't know. This article was relatively well received, but it's such a juxtaposition when I like look at the numbers. Like if I go here in my dashboard and we look at web components are not the future, released September 26th, and we look at the 54,000 viewers and hearts, and then you see this one here which has literally 20 times less reach or ownership. It's a beautiful contrast, because I can tell you out of these two articles which one is way more important than the other one, and it's not the one about web components. I can't imagine anything about web components being that important. So yeah, this article is one that I'm very proud of, and the work that we've been doing to get here is really important. I feel maybe some of the most important work that I've done in the last 3 or 4 years, but I don't think anyone's going to really recognize that until, you know, it's going to be a while, I imagine. But I want to talk about it today anyway, not just the article. I've actually been plowing ahead in this direction because it's a different audience. People care about the web component topic because it pressed a hot button, so to speak. This whole article series is the culmination of work that we've been doing around the Solid community for almost a decade. And you know, it's just it's one of those things, like even like Solid itself, I suspect that things will get more popular when other people adopt it rather than just on the sheer power of what we do ourselves. Not clickbaity enough, yeah. What are mutable signals? Yeah, exactly. What am I talking about, right? I'm going to drop this article down here just in case anyone hasn't read it as of yet. But, you know, actually, you know what? Maybe I should tell Twitter that we're live. Actually, no, I'm streaming live on Twitter, so they should know, yeah. This makes my life so much easier. Anyway. I should actually get Twitch going in the background too. Give me 2 secs. Because Twitch is where... Alright. Give me 2 seconds here. Yeah. This is a good time also to remind people to like and subscribe and comment and the whole thing. As always, helps a lot get more viewership, especially on important topics like what I want to talk about today. Because let's face it, I don't know how this stuff gets views otherwise. Okay, so what are mutable signals? I think the first thing I led with mutable signals because signals is a term that everyone's kind of associating with reactivity, but the reality is signals are immutable. Like at their core, signals are immutable. It was really funny because we've had this kind of immutable primitive for like over a decade. And I remember when the React team came in and they're all like mutation versus immutable. And it's like, no. A lot of people didn't realize this. Signals being immutable within their graph basically follow the same FP principles that React has, right? You could picture a world in which you built React using signals. You wouldn't do things fine-grained, but you could picture that, you know, a React component is a computed or a derived value. In fact, I don't know if anyone's ever done this kind of experiment or play around. I had an interesting conversation once with Dan Abramoff, kind of related, but it was like if you took a component that was basically a React component, and then you put I don't know if I actually have anything to show here, but like you could picture if you want to convert a React component into a solid component, usually all you'd have to do is just return a create memo and put all the content of the React component in it. Like inside the create memo, you can destructure, you can do literally every single Reactism, early returns, all of that stuff. But inside the memo, right? Because like inside here, this expression will always run again. So like if we had props or something, you know, and then we were like, okay, const, like pretend this is destructuring it in the component, you know, like you could basically go props and be like, I'm just gonna make it count here. And then we're gonna have return div. I'm not saying this is an efficient use of solid, but like render, let's just make a little app here, and document.get. Actually, this is what is it? Get element by ID. I'm trying to remember what the ID is on this one. It might be app, it might be root. Can I get a new playground? Let's see what this is. App, okay. It's app. All right, and then let's build something in here for a second just to kind of show what I wanted to show. Let's go const count equals createSignal. And sorry if I'm like spending way too much time on something really, really basic, but my point is comp count. Now obviously I'm doing this part in solid syntax. Button equals button, what is it? On click equals, we don't need the event. I know, I'm gonna fix the signal thing in a second. C +1. There's so much wrong with this, right? Count, set count, click. Okay. Render. All right, I have to actually import something from Solid. Import, create signal, create memo from SolidJS, and import render from SolidJS /web. Okay. Yay. Okay. Like, this is not good, but my point is, like, you at a really simplistic level, like, I mean, we could probably even make this whole thing, like, if we really dislike calling count as a function, I could put this in a memo and then so on. But what I'm getting at is, like, right, I was going to show you early returns, right? If count bigger than 5, return div large count. There we go. Like, there we go. Like, conceptually, within the scope of reactivity, signals are immutable. Oh, we could do document body. It's just, my understanding is that the playground has a special element for it, and then if you do body, you actually wipe out the playground itself, because, like, it also has other stuff in the document. I don't know if it's completely isolated. It might be now. Funny. Yeah, so what I'm getting at is, it's always possible to rerun things in a coarser manner, right? You can just merge them all together in some kind of expression. What does add to the return? I mean, it's just a function that gets the latest value. I mean, technically, if I'm really doing it here, we don't even need the create memo. We could probably just, we can just do this with a function, actually. You didn't miss anything yet, Dev. I'm literally just talking that signals are immutable. I think this is a fact that kind of surprises people, even though, like, there's a huge similarity, like, when you, like, look at things from far away or close, between the reactive graph and, say, the component graph. The difference is one generally operates on data and one operates on view. I mean, even when you think of server components and the way the React team views their server components as data, essentially, like, their view data, like, essentially, like, it's a part of the graph that returns view, instead of data, right? When we work on Solid, or this is similar with Tanner's mentality, he's dealing with data primarily. Like, that's what he's thinking about. He's like, how can I make my data most efficient and manage that so that my projections of said data are minimal? Reactive's like, don't worry about that separation. We're all just going to bung it all together anyways. So, like, who cares? Well, there's reasons to care, but that's what we're going to talk about today, right? Like, at a conceptual level, we've kind of, like, here's our, like, simple recreation of React. All right. So everyone's still with me so far. I don't think this is crazily complicated, to be fair, but I would say that one day. Right. A lot of research is modeling circuits, real-time systems. Yeah, I mean, this article, I talk a bit about how when I first saw Svelte 3 and later the React compiler, people challenged that these frameworks are fine-grained in their rendering. And to be honest, they share a lot of the same characteristics. If we were to end the story with signals and derived primitives we've seen so far, you could argue equivalence, except for these systems not allowing the reactive to live outside the UI components, right? The first thing you start seeing is, like, when you have this control to be able to do this kind of thing, you have the means of making it portable, right? Rich Harris just gave a talk at VConf. And I think it was something like, what is it? Rich Harris VConf. Svelte 5 Beyond Components is what he called it. And it's just funny. You, like, once you land here, this is the revelation, right? Because if I type in world beyond components, you're going to see my talks in the last 3 years. Like this is basically the whole premise of what we've been doing with Solid, right? Right. So like this is what fine-grained gives you, but it's more than that. It's more than granular updates, right? Just on a subsurface, because Svelte 3 and the React compiler sort of have these granular updates. It's actually very hard to observe because of the granularity, the difference between something written in Solid or Svelte 3, or sorry, written in Solid from Svelte 3 or the React compiler. Because the only places in the code where you have access to write stuff in are essentially the side effects. So you can only sneak a console log into a place where the framework does side effects. And for that reason, it's not observable, the internals of the framework here, even though in reality, Svelte 3 and the React compiler do more work. So what is the difference? What is the key difference? Right. I assume that in this code, the div we created every time. Exactly. Right. Like the reason we don't do this in Solid, right? This is Vue actually. Like if you look at this is Vue. Vue has a JSX form where they return the function. Like this is Vue. If I put like, right, Vue is a VDOM library where you put your state up here and then you put your template down here, right? Right. Well, that's what I'm getting at. I don't know if it's an interesting question because I worked on advanced compilers when I was working on Marco, and in some ways it's not as advanced as the React compiler, but in other ways it's further along this path because it was doing cross-modular analysis to the point that it understood exactly everything that was reactive in your whole application from a graph standpoint and all the dependencies, and was able to, like, this is more than what the Svelte compiler does, and it's doing something similar to React compiler, but in an actually maybe more informed way. React has compiler is a lot more complicated because it's smarter around like certain typing type stuff, whereas Marco, the syntax is so explicit, the job's actually easier to have greater analysis. And Marco does not solve the problem that I'm going to talk about today. They ended up moving to a runtime reactive system on top of their compiler, kind of similar to what Svelte's doing. Still better informed because of the cross-modular stuff, which is a place that Svelte could go perhaps in the future if that's like so their intent. But I don't think you're going to see a React compiler be able to produce what I'm going to show you today. I don't know if it's like theoretically possible. It might be. I don't want to say never, but yes, sorry. This is the problem. Like, I don't want to, right now this is just a div. Picture if this was actually heavy. You don't want to do this work every time. This is why you don't do this in Solid, right? I mean, you can write this in Solid in a different way, right? You can just write this with like a show component or some other way. Like the best way to write this component in Solid would be like this: return div props.count bigger than 5. Large count props.count, something like that. This is the more efficient way of writing in Solid. Let's format the document. I guess this is still short enough that it fits in a one-liner. But it's funny. This early returns thing is actually going to come up again maybe later when we talk about Dominic and This Week in JavaScript. I don't know if I want to divert there right at this moment, but this was also another topic. Separation of UI and logic used to be a thing. Yeah, it's a funny thing because there is a separation, but there's such a huge overlap that both extremes are kind of terrible, right? Like if you try to overlap them too much, arguably what React does, you end up getting sort of trapped by that fact a little bit. These inefficiencies show up. But if you try and keep them separate, you can be more efficient, but it gets a lot clunkier. There's a lot of duplication. So like the key is recognizing that there is an overlap. And I tend to lean closer towards React because I think that overlap is like the 70 or 80% case. But you have to leave the door open for the other 20. Yeah, I had a similar problem, right? And disabling change checking. Yeah, it's the thing is that's fine too, but you have to understand when you do this, when you say always notify and you do stuff, you're telling everyone downstream that it's their responsibility for diffing what actually has changed, right? Now, like if it's fundamentally a stream conceptually where every single element that comes down should be seen as a distinct thing, then yes, that makes a lot of sense. But if you're just mutating data and you don't want to, like, you're basically just pushing the work downstream if this value should be viewed not as a stream but as an actual value. There's a better option is what I'm getting at. Yeah. Oh, okay. So you're talking about some kind of rendering consideration. Yeah, because like what happens here now is this div only renders once now. Before we weren't looking at it, but like, is this even worth looking at? But you all know that if I click this, you're only going to see like even though this flashes, it's not actually re-rendering. It's literally just this text changing. Anyway, whereas before you would have seen the whole div like unmount, but that's something else. Let's continue on. All right. So what do I? Yeah, this is just showing that fundamental thing, right? If you create an effect, based on a signal, if you go and update the thing without calling the setter, the effect's not going to trigger because it doesn't listen deeply. Whereas if you set it with a new object, it will run again, essentially. Like this deep mutation is not like the reactive system. The whole key to reactive system is that it knows when you set the value. It looks for the set on the specific property, the specific function, whatever it is. It calls a function in the background and it reads with a function. If you don't intercept the read or the write, it breaks. You have to intercept both sides. Right. So I'm just kind of talking about the fact that like a reactive graph is essentially this kind of immutable, I'd say stream, but not in the pure sense of the stream, but like stuff progresses through, right? In this example, I have a start log, and then I go, whatever the pre's value, which, let's say it's nothing, plus whatever the current log is. So start, and then when the effect runs the first time, it's going to log start. And then when the effect logs, when we set this one, the previous can get appended. What I'm trying to show here is that we have the ability to do what I call reducing operations within derived values. Essentially, like computed is a function of its reactive inputs, but it's also possible, depending on the design of the computed, to also be a function of its previous output. So like this is very common in in uh, in immutable setups, because what it lets you do is you can look at the new inputs, you can look at the previous value, and then you can diff those to kind of decide, compare them to kind of decide how to move forward. You always have this previous value, which is immutable, fixed in time, to fall back on, right? So yeah, let's look at this example a bit. We're going to focus on an example here for a second. You're still not sure if signals should be reduced. It's not possible to miss updates, especially after getting lazy. Well, that's the thing. Signals are fundamentally different than streams because they aren't streams. like because it doesn't matter. Their only responsibility is they are a value conceptually. It doesn't matter the journey. They are the value, which makes effects interesting, because you have the same question about effects. Should effects see every possible permutation of the input values that come in, right? It's interesting, right? Like if you were trying to log every change to a value, effects actually don't really help you there per se if within a given time frame you do multiple updates. The whole idea, at least with signals, is that they are a value conceptually, not a stream, and that the goal of effects isn't to serve as the log, which is funny because that's the example I used, but as a way of doing external synchronization with the current state. It's funny because this ties into another conversation on Twitter. There's some Vue guy going like, how do I make an effect not run the first time in Svelte? And it's like, that's a weird ask, funnily enough. But yeah, I mean, reducing computations or whatever are similar to the scan operator. It's the old joke where you could write Redux in one line of code using was it fold or scan with RxJS. Like here's Redux. Create memo is also Redux in one line of code. Signals are a value that changes time. Stream is a time containing different values. Yeah, exactly. There's a fundamental difference here. It's a huge optimization artifact, right? Because this is the whole purpose for a signal system. It's not so that you capture every single thing that has changed in the stream. It's so that you can keep stuff at sync at the rate that the consumer can handle it, right? You have to make sure that if you're updating a third-party system, that could be including the DOM, something outside of the reactive system, you want to make sure that at any snapshot that it's consistent. That's the guarantee that we have. We're not guaranteeing that we don't miss any intermediate states. We're just guaranteeing that it's consistent. Yes. I mean, is it as fine-grained as possible? Depends, right? Like, it depends on what's causing the effect not to run. Like this part isn't so much where my definition of fine-grained falls. Like the goal of fine-grained is being able to apply changes in a granular fashion, not the fact that it's lossy or not, right? Like time is not really something that signals are worried about. They don't have a concept of time. They just are like, am I consistent? It's like it really is like an electric circuit. Like short of specific mechanisms like buffers or whatever, electric circuit only exists in the state that it's observed in, right? Like, when you talk about digital clock cycles and stuff, like the circuit is like true physical reality doesn't mirror this, but all models based on it is that you can only really exist in one state at any given time. Yeah, pre-code the stream, of course, yeah. User only cares about the next animation frame. Yeah, for example, yeah, that's a great example, right? Our concern is only as far as synchronizing with the system that consumes it. Yeah, our RxJS has a lot of things, but like their behavior subjects generally aren't implemented like signals with the same guarantees. They aren't as concerned with this consistency thing. Subjects are like signals in that they are a value. They don't care. I think they're lossy. Like they don't care about the stream as much. But the biggest reason that signal implementations are a thing is because of the guarantees we have on propagation, because signals are synchronous. Going to async is a whole other topic, which we've covered, and we might do a little bit today if we have time, but yeah. If a signal falls in the forest and there's no effective server, nothing happens. There we go. Thank you, Greg. That's okay. So, okay, let's kind of continue on. I made an example here where I wanted to show how we break apart from our immutable reality, right? Because this is immutable, not much different than React. But what if we put signals in signals and effects in effects? Right. So the idea here is there's a user object. And the funny thing, this is like completely what we used to do in the knockout days, because you get some fresh data from the server and then you like create a signal for each property or something. Right. This is before we had proxies and whatever, which we'll get to, but this is the same concept. Pretend now, instead of just having our singular signal, we, when we create a user, we actually end up creating a signal for that user, which in turn has a signal for its name. So here what we're doing is we're like creating a signal for a user, right? And we're making a new user object here. And in the process of wrapping it, we're also creating a signal for the name. And then we have an effect that listens to the user, gets the U out, and then we have a nested effect which gets the name out. So when this first runs, it'll run console log user ID, and then it'll console log name user ID, right? So user one, name John. Now, if we set a new user, kind of like the immutable approach, when you just swap the whole user out, maybe fresh data from the server, we end up creating a new signal for the name and putting it through, and you're going to see both things log again. It's going to log user2 and now name Jack, right? Because it will trigger rerunning this thing, which will console log it and console log this. But if we just go in and change Jack's name to Janet by just setting the name, we only need to rerun the internal effect. It's only the nearest effect that runs. So when we swap out user, we swap out this whole block. But when we swap out name, we only need to run this thing. And this is interesting because we found a way of doing less work, right? Yeah, with Mapple Ray. I mean, this is the key. This is basically the whole premise of like fine-grained rendering, essentially. But what I'm getting at here is this system is no longer immutable. Because we're actually changing the user's name. We're not replacing the whole user, right? Originally, we could have just swapped it out, but for this system, we're actually now changing the user's name. If we didn't have the means to individually set the name, this internal effect wouldn't do anything. It would always rerun this, right? Like, we don't need to go this way. We could keep it immutable if we wanted to, right? By not adding the nested signal. This is what I was talking about earlier with React, everything being a memo. Like picture now if we just created a user and created our effect. And now when we set the user and then we update that user's name to Janet, we're swapping the whole thing. All we have to do is get the user and diff the values. And if the values are different or not, console log the right thing. So the first time we get the new user and we see that, hey, this user's ID is not the same. So we're going to actually console log the user ID. And then we go, oh, this name is not the same. and we do John. So the first time it runs, it's brand new, so it does both. Then we set user ID 2, name Jack, and it does both. And then the last time, the ID hasn't changed between these two, so it doesn't run this and only runs the second one. So this is React, essentially, right? This is immutable change. It has the exact same logs as before, right? Except you did it without nesting signals and without nesting effects. I'm always worried about memory leaks. That was an old problem. It's one that's been solved largely now because there's a reason. First of all, biggest problem with these observer patterns is that they go back and forth, right? Like even though only one side needs a subscription, we do the other side so that we can do the proper cleanup. So they subscribe on both sides, which means that if left alone, unless both are released, like lose reference, they will memory leak in theory. But what we have going for us that's beneficial is that in modern reactive systems, at least, or it's why Solid has that really annoying warning about this is created outside of a root, blah blah blah. You know the warning. Essentially, on the effect side, when we create an effect under an effect, you kind of know, like, if we create this and then we create this one under. So when this one reruns, that's fine. But when this one reruns, you're creating a new effect. Like, you're running all of this code. So every time an effect reruns, if it had any child effects, we release them the same way we release the dependencies. So if we release this effect, when this effect reruns or when it's released itself, then this subscription to the signal will be undone, which means that half of the dependency is gone, which means that the effect is free to dispose of itself, and the signal is also free to dispose of itself if it ever loses reference. So, like, the memory leak problem actually has not, like, I used to have memory leak problems in Knockout a lot. Since moving to Solid, like, the memory leak thing has just not been a thing. Signia either has global signals, mostly when you use it with React, or they're tying into React's lifecycle. But given that I'm not actually completely sure, but this was the innovation that Surplus added to the front end. This is what made fine-grained rendering possible, like with SJS. Otherwise, you'd have to depend on like component structures. Vue didn't have this means before, but they've been adding, I forget what it's called, but they've added something with Vue 3 that has this kind of release. Svelte is based on this mechanism now too with Svelte 5. But this has been since SJS back in, or Surplus, I guess, back in, because SJS was created in 2012. I think Surplus came around 2015 or 16 time period. This mechanism has been around, and we adopted it immediately in Solid back in 2017. Well, here's the thing. It could be documented, but like, I don't know if you really want to do this all the time. We'll get to this in a minute, but I'll show why. It's fine. Like, technically this is how the rendering works, but like, I think you'll find when you do your real life problems, like at a less scale, you're not going to find yourself doing this all too often. You might, but let's continue on for a little bit. Okay, so we get this. The biggest difference is it's not that expensive, but every time you do this change, you have no choice but to run all of this. Whereas when you do granular changes, like this one here, it is only this code that's run, right? This always runs everything. Given that diffing is fairly performant and that mapping over data, especially deeply nested, is cumbersome, people generally have opted for the latter. React is basically this, what I just showed. However, diffing only gets more expensive as our data and work related to it increases. Once resigning to diffing, it is unavoidable. We lose information. You can see that in the example. When we set the name to Janet, in the first example, we were telling the program to update the name to set Janet. In the second update, we're setting a whole new user, and the program needs to figure out what has changed everywhere the user is consumed. Like, obviously we're only doing the diff here in the single effect, but the point is, when you go this way, when you're setting a whole new value, or you say like we mutated name, and it's the same value, and you turned off the equality check, we're pushing the work down the line, right? So this the whole point is, this is why we came up with stores, right? Essentially using proxies, because Vue has Vue's reactive is very similar, and Svelte recently has their state object and the ruins actually are also proxy stores. We'll talk a bit more about trade-offs with those designs in a moment, but the idea here is, this is the thing that is hard for a compiler or React to do, which is essentially this idea that these are nested proxies, and that we can have our code here, like our double nested effects, and we still have the means here to either replace the name or update or replace the user, let's say, or update the name. This actually isn't, it's funny, I use this example, but this is not actually how our stores work. I guess it's how our stores work today, but this isn't. So this is like a weird, I mean, these effects are different too. This is like a weird pseudo place between Solid 2.0 and Solid 1.0. I'm hoping it's still illustrative, but my point with this example is that when you have proxies, you have the potential to still replace the whole user and trigger both, or just update the one thing. And instead of going through all this wrapper extra stuff that we had here, like this was the cumbersome part, we essentially get a version that looks almost like on the creation side, it's as simple as like the immutable version, which made the creation simple and the update simple, but made the like effect complicated, right? Whereas this version, the effect is easy, but you had all this creation stuff. The proxy version actually is the best of both worlds. You have the simple effect and you have the simple creation. What's the pattern with create effect if there's more than one signal? I'm not quite following the question. Like, it tracks all of them, but so if you have, like in these examples, if you had more than one signal here, you would have to, diff all the differences between all the signals. And with my nested example, you'd either have separate effects listening to each signal, or parts of signals, or it really depends on what we're rendering here. I'm not quite sure I understand the question. Yes, yeah. This is an old FPS conversation, right? It's like if you know anything about game rendering, the biggest they traditionally do like immutable changes where you like re-render the scene, and the whole argument there was that FPS is kind of consistent. You can predict it, right? Regardless of what work you have to do, the cost is the same. So regardless of the update, you always get the same cost. Whereas when you have these granular systems, it can go between the update doing basically zero work to the update doing all the work. So this was long used in like the game industry in terms of justifying like the mentality. A lot of moving parts. It's easier just to re-render the graph, consistency. There's lots of reasons to kind of take this perspective. But on the other hand, we know theoretically it's not the most efficient way of doing things. Well, I think there's still space here, which is why we're talking about today. If we did it today, I like, would you do it like Vue and Svelte, where their signals just become proxies kind of automatically? Like if you have a ref in Vue, not an explicitly shallow ref, or you stayed in Svelte, they automatically become proxies as you get deeply nested data. We don't do that in Solid. So there's like interesting repercussions, which I think we should continue looking at. Does the nesting actually do anything? Yes. In the create store example, it does, because it's the same thing. Where is it? Where am I looking at? Yeah, because on this side it runs both, because let's say we're setting a new object. So in this, like, I'm kind of leveraging the fact that we're using proxy access. So user.id here, it's the .id that's tracking technically. So like when it saw the ID change, it reran the whole thing. But here where, yeah, like this example is kind of, yeah, this example is bad, and I'm glad that we're bringing it to attention that it's bad. But here, by only updating the name, like the name, you're not hitting this. You're hitting only user.name, which means that it's only running the inner effect. Generally speaking, with stores, you either write to it in an event or you write to it in an effect. You don't write to stores in a pure derived way, because it breaks the graph. I've covered this before. You could, right? In this particular example, you could. The benefit of the nesting is more apparent when these have state created under them, because you can put createSignal inside the effect, right? So like pretend this effect had a createSignal in it that was also read in here. So like this is how Svelte 5 works essentially with the component, like, because you can nest state in an effect graph essentially, right? Components aren't really components. They're like, it's the decision points, like the control flow, that actually define things, right? This is how Solid renders, and this is how, like, obviously in trivial cases we can pull this out, but sometimes the closure between this scope and the underlying scope is actually relevant. Like you create state in here, and then that state is read in here, and then you don't want to like reset it unless the inner or the outer scope reruns. Yeah, I was mostly just trying to show the independent updates. Right, so what did I say here? Why does this matter? Picture if you had a list of users instead. Consider an immutable change. Yeah, right. If you've ever updated a list of users, right, you can map over a list, and then you go, find me the user with the ID. So you go through and you go, if the user's not this ID, just return the existing user in the map. Otherwise, copy the user and add the new name. This is how you do an immutable change in like React or most things. You have a list of users. You go change the ID with this name. You return a new list with the user with the updated name, right? But with mutable change, you could just find the user and assign the name, right? And if you think about the repercussions between these two operations in the scope, it's a huge difference, because this one, the framework or whatever, gets a list, an array, a new array with all the same users except for one that has a name. So when it goes and iterates over to Diff, it's going to be like, okay, I need to run the logic that does the array diffing. And then it goes, okay, let's go through each one. Hasn't changed, hasn't changed, hasn't changed, hasn't changed, hasn't changed, hasn't changed, 200 times. It finds the one that has changed and goes, okay, what's changed about me? So then it goes through and it needs to go, okay, has the ID changed? Has the title changed? Has the thing, oh, the name has changed, update that. That's the process that you get with immutable change, right? Even with the memoizing compiler or whatever you're doing, you're essentially going to run through the whole list and then do a bunch of these really quick shallow checks and nested shallow checks and so on. But with immutable change, you literally go, oh, update the one signal with the name. So instead of running anything, you don't have to tell the list to update. In this case, you didn't actually update the list. It's the same list reference. It's the same user reference. It's just like the one place in the DOM where the name is. It just goes ping, update that. You didn't have to do any of that, right? The one signal updates. No list recreation, no list diffing, no row recreation, no DOM diffing. By treating immutable reactivity as first-class instance, we get the authoring experience similar to immutable state with the capabilities that even the smartest compiler cannot achieve. But we aren't here to talk about reactive stores exactly. What does this have to do with derivations? Oh, what's the argument for set user if using proxies anyway? Well, big one for me is the loss of scope, right? I'm still a big believer of unidirectional flow, and like the like I love that I have articles for all of these topics now. Let me see if I can open link in a new tab. React, I've written this article like twice actually, to be fair. I wrote it like in 2018 the first time. Two-way binding is a two-way street is a good one, but the one I'm looking for here is thinking locally with signals. This is a whole argument for basically saying that React has all the same benefit, or sorry, Solid and signals have all the same benefit of something like React. Like it's not like something like the world goes crazy. It's just there's the classic example where you like go, I have an object, you pass it to some function, and then it's like, can you say anything about that object afterwards when you pass it to the function if there's the expectation of it being mutated? So there's like this control that you get by having a separate setter where you're saying like, I'm explicitly letting it, like, even though Solid has it's like the first step there. Like when I create stores, especially global stores and stuff, I generally create actions, right? Like I won't pass the setter straight down. I'll actually like make a pattern. Like it'll look something like, you know, something along the lines of like, you'd use the store something like, you know, here's our store, and then you'd be like increment, decrement. Like this, I usually keep the same thing, right? So create my store or whatever, right? Like this is the pattern I usually use because I actually wrap the specific operations. But if you look at it from a DOM standpoint, even like when you're passing stuff to a component, on click, on save, you're actually at a component level defining the actions that you pass through, because then you call the setter here, right? Set store, whatever, right? So in a sense, to be fair, if your reactivity was limited to your local scope, which is something that Svelte does to a certain degree, it doesn't completely though. I did a whole stream about this. I was really excited about Svelte's ruins from the perspective of not letting reactivity just flow everywhere. But then I found out from Rich that they don't actually do that. So I got really disappointed and decided that I didn't actually care about ruins that much after all. But, and I found problems and why they did it the way they did, which means that it doesn't solve what I want to solve, which means that, you know, it doesn't do what I need it to do. But generally speaking, there is an incredible power to being able to control and say like, no, you don't get to update this. You can. And there's another reason. There's another reason, which this is why I think these things are important, because yeah, derived values, we know them are immutable, right? Okay, so yeah, I want to talk about deriving mutable things, because I told you most frameworks have stores, but not every framework has derived mutable stuff. Their derivations generally are immutable, even with derived state. Like, don't get me wrong, there's benefits to that. Might look at that a bit later, but generally speaking, derivations are immutable, and it makes sense, right? We have a function that runs and returns the next. Like, look, like I've been using this, if you've been noticing, all throughout this whole series of articles, state equals function of state, and it's because it, like, at its core, derivation is generally immutable. Like you get the previous state to get the next state out. It's a function call. When the inputs change, they rerun, you get the next value. They serve a couple important roles in Reactive Graph. First, they serve the memoization point. They can save work on expensive or async calculations if we recognize the inputs haven't changed. And we can use the value multiple times without recalculating it. Secondly, they act as a convergence of nodes. And this is what I was kind of hinting at earlier when we were talking about like React. They are joins in the graph. Like generally speaking, you have a bunch of different data points. And then when you end up deriving stuff, you're usually combining these values together, right? You might go take a name and a format signal, and then you get a formatted name. These essentially act, even into the DOM to a certain degree. You end up derived values generally are like sometimes they're just a transformation, but quite often they're a convergence. You always start from multi and you narrow it down. There's no convergent nodes in React though. Is that true? I guess it's not granular enough. Like you can't converge something when the whole thing is already like one thing. I mean, you could argue that components are, right? Because components take multiple props and aspects in and bring them in. Yeah, but from an update cycle, React doesn't ever diverge. Once a parent is like you are updating, short of shortcutting, which is different than divergence, you are literally updating everything below it. You go, this has changed, everything below it needs to get blown away, right? So like, it might diverge in UI aspect, but at that point, you do a change, the whole thing is a single tree from like a single push out from things. Yes, they can shortcut with memos, but like you're in it from that point. You are doing everything below. Yeah, components are totally convergent nodes. Well, we already showed that. Remember when I showed a React component is just a create memo return? Like it's if you kind of take that aspect, so I call them joins in our graph. They tie multiple different sources together, defining their relationship. This is key to understanding updates, but it also goes to why the finite number of sources increasing dependency would become entangled. Oh, this makes me really sad. This is gone now. I wish I'd taken a screenshot of it. Seb from the React core team, he moved to Blue Sky today or yesterday, and he deleted all his tweets on his account except for one with the blue sky icon, and it removed the picture here because it was a embed from Seb's Twitter, which basically he said for those of you guys who don't know, Sebastian Marcabate, I think his name is, he's like the visionary behind React for like after Jordan Walk kind of stepped away from it. For the last decade, he's basically been the man, so to speak. Like there's multiple people on the team, but he's basically like and to be fair, Facebook's a big company and they have all different things. But if you want to as close as like myself to Solid, Rich Harris to Svelte, or Evan Yu to Vue, it's not Dan Abramoff, despite popular belief. It's actually Seb. And he said something along the lines of his problem with fine-grained reactivity. Yeah, he's at Vercel now. Yes, exactly. Yeah, I mean, if I can get it back, I will replace it with it. But this is unfortunate because I think I used their quotes in a number of my articles. I should have not used embeds. I did it so that it would like link through, and I was thinking, oh, clever, but like who's going to delete their Twitter? Well, Dan Abramoff, I think, did it at 1.2, right? Yeah, but essentially, he said that his problem with fine-grained reactivity was essentially the fact that by nature everything ends up converging anyways. So like any gains you get basically go to waste. It's like basically pointless. Like everything just converges. Which makes a lot of sense. With derived immutable data structures, you only have joins. You don't have forks. As complexity scales, you're destined to merge. Interestingly, reactive stores don't have this property. Individual parts update independently. So how do we apply this to derivations? Right? So Anders Stoltz published an amazing article several years back where he linked together all the types of reactive iterable primitives. Honestly, if I told you earlier in the stream that I like love his writing, I'm just gonna throw this out here. This is like one of those like articles of like it's such a systematic way of thinking and approaching the problem. He basically defines everything on the basis of like JavaScript is functions or functional programming is functions, whatever thing floats your boat, right? So he's like, look, at the base you have a value or object, right? And then you have a function which is, you know, x returns y. And then he goes on and goes, then you can have getters, which is, you know, a more specific version where you're, you know, no input gets x, right? And similarly, you can have a setter where the input, you know, impacts things. Yeah, this has always been for me, like I've associated with under, because this is not the first version of this. He had done like most of it, and then like he finally got the missing piece. Like this is a sequel to an article he'd written about 2 years earlier. But the idea is, as he kept on layering on stuff, getter, setter, which is these, by the way, this is the cornerstones of signals here, right? Getter, setter. Getter, so it's a getter that gets a getter. And guess what? You can have setter setters. And I think you can actually have getter setters, to be fair. Like there's a little bit more space in here, but it's like a setter that takes a setter, essentially. Like, so you can dynamically pass in the setter that will be used, right? Whereas a getter is a getter that returns a getter. Okay. Why am I going with this? Well, because he started recognizing that like iterables are a type of getter, and that promises are a type of setter, right? And observables are also a type of setter. So he just kept on building it out, and then he's like, and async iterables are actually, you know, iterables with promises. And anyways, he was using the shape of the API to actually define the characteristics of the type of solutions you could have as a way of sort of confirming with himself that he explored the whole space of the potential of, you know, these potentially reactive operators, right? This is absolutely brilliant because he managed to like kind of observe the shape of the pattern to kind of understand. Like, I'm sure there's other setters and other getters, but he painted a whole picture on how these primitives are related to each other. And he did it all by understanding their nature by the shape of their API. And I actually had a similar kind of experiment when I was working getter setter. Well, that's exactly where I'm going to go to right now. 2 years ago, everyone knows how much I care about derivation, right? But I was like, I was like, okay, we're gonna start working on Solid 2.0, right? Just over 2 years ago, maybe 2.5 years ago, and I started talking about characteristics of you know, things that I considered important. And I basically at some point decided that we needed to kind of reconsider our primitives, right? And this was like a lot of, like, I was just saying what aspects of reactivity I thought is important, like evaluate on pull, like being push pull, you know, this is high importance, and I'm very confident in our solution, right? High level direction, generating create computed, writable memos. So I first put out this proposal, and this is based on old knockout and view style writables. And I was like, no, this isn't what I want to do. I was like, because this whole approach is very similar to just having a memo, which then kind of wrote back to the source signals. What I realized is from a shape perspective, this wasn't a two-way thing. See, old two-way binding frameworks had this way that you could like have a computed value that you could write to, so that when you pulled the value, it did the computation, and when you wrote to it, you wrote back to it and then transformed it from the, you know, what would be considered the transformed version back to the base version so it could get pulled again. For example, this full name thing is a classic example of this, where the idea is you could make a full name, set full name. And then what would happen is when you basically grab the full name, you would get first, last with a space in it. And then when you set it, it would split the full name you gave it by the space and then set the two signals under the hood. This is how this worked in Vue and in Knockout. But I was like, why bother with this when you could just wrap this whole create hypothetical writable thing could just be written with a memo that, you know, basically this. You can easily see how you could just wrap this in your own function and do this. You didn't need a special primitive to get this functionality. Right. CreateWritable is a getter or Angular link single. Yeah, Angular very recently added this ability that I was talking about here a couple years ago. Svelte has a linked signal as well, I believe. I don't know between Svelte or Angular. I think I saw a post in a Discord where Dominic was sharing it, and the Angular guys were like, they both call them linked signals, which makes me think that it was a conversation between those two, where the naming finally listed. Oh, you ditched it? Okay, good to know. Because I think you didn't ditch it before influencing Angular to go with it. What was interesting was what I wanted was almost like a controlled component. Like I wanted something that would be mutable and then it would reset when the stuff updated. And the reason for this is one of the worst problems for synchronize, like I've written about this before in our and we've covered it on stream before, but essentially, how many times have people written a component and done something like this? Name, set name equals createSignal props.name create effect, let's say for sake, set name props.name. Basically, some way of keeping it in some way of keeping it in sync. This is terrible from a reactivity standpoint. React tells you not to do it, even themselves. They're like, no, you can actually just set it synchronously. You know, it's actually better, like in React, it's actually better to just do this when it reruns the component. In Solid, we actually were like, well, use create computed. It runs without triggering rendering. But I'm trying to get rid of create computed. The reason this is bad is because the name, it breaks the graph. The name doesn't know that it depends on props.name. Like this could be empty and it'd actually still work. My point is there's no connection between this source and this name. Like this write could happen anywhere. Yeah, I'm going to call this create effect. It's easier for people to see it. So like it means that when you have graph propagation, it like stops there. It doesn't realize, you know, like first of all, it basically triggers a whole nother reactive update by doing it this way. Like the first change, the props name, like if props name was used somewhere else, like in your div, like if we had a div here that was like props.name and the name, like if we put both side by side, there would be a short period of time where these names would not match. remember, consistency matters. It's because we can't know. You basically broke the graph. Never, like, there isn't a problem with using effects to write to state, but using it as a synchronization mechanism is bad. If you want to use an effect to write to state, it's because you're reading from the DOM. You're doing like an animation or something. It's not for this. This should never do this. And the problem is there just isn't a good solution to solve this. And I was like, I knew that from the shape. I knew from the shape that I wanted it like this, because in theory, you can see that field depends on props.field. I didn't know how I was going to implement it, but I knew that it is, right? Like, here's the example again, right? And then, so I put it out there, and then Milo came back, and he was like, we can just do this. Let me highlight this code so you can take a look at it. Really simple. This isn't the full version with the previous values, but you can see the point. He made a computed, which is a memo that creates a signal in it based on the function you pass in. So, props.name here or whatever. So this signal will be set with props.name, right? Let's actually just make this the thing. PropsWritable, props.name, okay? Let's look at this. There we go. So it runs this function that we pass to it and creates a signal with this value. And that signal is returned to a memo, which is here. And then it returns our getter and our setter. So what happens is this getter gets the computed, gets the first element of the array, which is the getter side, and calls the getter. So that's easy. Basically, when you read from this name, you're actually depending on both this signal and this memo, right? It's nested like our effect example. And then on this side, when you write the value, it calls the computed. So it depends on the read of the memo, and then it calls the write of the signal. So in essence, what happens is the graph is not broken here, because when props name changes, anything that listens to name knows that it actually listens to both this memo, which means it actually listens to props.name kind of indirectly. And then when you do a write, it just updates the internal signal, right? But if this function triggers again, it reruns and creates a new signal, and this still gets notified, and this write function gets updated. It only returns a new signal when props.name changes, not when you set name. Right? I can think of more efficient ways to implement this, but this is a very fundamentals, right? Because I told you a moment ago, this is higher order. It's just a getter and a getter setter, right? What do you got for me, Dev? You trying to derail me with something? What are we doing here? Also, thanks for this. Also, thanks for the sub. What do we got here? What do you got for me, Dev? Update. It's now a third order signal. Higher order lazy signals coming in clutch now. A signal for actual value coming from the server wrapped inside a lazy memo so that it only runs when it's read, wrapped inside an async memo that holds deserialized payload from the server, which is wrapped in a proxy. I don't necessarily want to think about what that means, but yes, I think there's a whole design space when you start considering the composition of signals. What happened if it calls set name? I don't get it. Okay. Well, if you call set name, it's this memo is just returning the signal, and then you're calling the setter on it. The reason there's these array syntax is in solid create signal returns an array. So this returns an array here. So you're calling the memo, like when you call the set, it's just overriding the signal inside here. And because you're accessing it here, the second one, it's retriggering whatever's calling this here. So you're just like, you're basically just reading the create memo, which goes nothing's changed. Whenever you call, whenever you call set, it basically goes, first it goes calling the memo, nothing's changed, call the set on it, which then triggers this side, the get, wherever it's used, and it goes, calls the memo and goes, oh, nothing's changed, and then gets 0, and then reads this and gets the new value. The reason we did the initial link was because Dominic implemented with Derived, but it had problems. Let's see if I remember the problems we had. Okay, interesting. So like you start seeing that like there's a whole other dimension here by following the shape. I mean, you can write it right now like this or a variation of this, but yes, the answer is yes. And let me show you why. Because yeah, so getter, setter. It occurred to me while writing the previous version of this article about, I actually complain about, let me see if I go here. In the previous article that I wrote in the summer, beginning of August, I actually complain about the fact that the one inconsistency in React is that, like, this is don't do this. Remember, this is the same thing I was showing before with the createWritable. But basically, over the process of writing this series, what I realized was that this is such a common thing that it's not much of a stretch to just make createSignal work this way. So the plan isn't actually to ship createWritable. It's literally just that if you pass a function to signal, now it's a derived signal, because that's the mentality here. One of the weirdest things, and I think I pointed this out on a stream before, is if you use React and so you have a function, like so my comp, right? And you kind of go in here and you go const count set count equals uState props dot count. Okay, so const double count equals use memo props dot count times 2, and then we'll just do props dot count. Even though the component reruns, so if the props count changes and the component reruns, in React, it will see that the memo has changed and reevaluate it and get a new double count, right? But this doesn't reevaluate. This is only the initial value. The only hook that runs something top level that doesn't like invalidate, it's not a dependency array to be fair, but it is odd. You know what I mean? Like the only one that doesn't do it is uState. Like for something that always redoes all the work, that goes, okay, we check and we rerun the whole component. This is the one that doesn't update. And essentially, like, I did a little bit of work, a little bit of stuff I was playing around with. I mean, I'll probably load a playground up for that too. I have the latest Solid 2.0 reactivity stuff, obviously the demo, like I've got it here, but essentially, what I'm getting at here is it occurred to me that we could, like, do I have the code here? Let's go create signal. we could, detect if it's a function and create a memo in that case, which adds a little bit of code, but like what thing doesn't have create memo in it? And where I was getting at here is create memo itself can be set up so that when it reads, if there's no dependencies for it, like it doesn't track anything, it's possible. That's what this is doing. This is just compiled down. You can basically delete the node and in the future just return the closed over value. So you can actually release that memo if it's not necessary. Because the one problem with an API that takes a function is like, how do you store a function as signal? Well, we have this already in Solid. If you've ever used Solid and you store a function in it today, I guess I should turn TypeScript on to show you this. You can go like, you can make a signal with a function and you can go create signal and pass in a function, okay? Doesn't really matter what the function is. But when you try and go set function, right, and update that function, you can't just, if you just do this, it's going to error at you because it's like, because we have a functional setter. We saw it up here, right? Count plus C. Because we have a functional setter, if you want to store a function, you have to set it. You actually have to do that. You have to pass in you have to use the function form if you want to set a function. And because of that, it's actually more consistent if you had to also pass in a function to set a function here. So there is this like small edge case where you want to store a function as signal and it's not reactive. So I've made it so that it releases in that case. There's other benefits of memos releasing when they have no dependencies anyways, but like essentially it's actually symmetrical. So and the positive of this kind of approach is that there's no new import, no new concept, no nothing. I'm creating a signal. Is my signal, where is it here? Is my signal based on a value or does it depend on something? Ta-da, right? This is, it didn't even occur to me to make it, like I'd createWritable, but then once I realized that this is such a common thing, why not just make it the thing? Like the problem with the create effect update loop, this thing is people get here because they know signals and then they go like, okay, how do I possibly like make this update with this? And they go for the signal API. They don't know about createWritable or create other thing. So I was like, what, can we just shortcut this and just be like, that is what a signal is? Anyway, we're barely scratching the surface. There's way cooler stuff. This is the least interesting part of today. So what I'm getting at here is it's an interesting exercise when you follow the shape. But the truth is this is not a writable derivative. Technically speaking, this is still immutable. This is still a signal. We haven't actually solved the problem. You have to differentiate the case because there's a difference conceptually between creating a signal like from count like this, let's say, and creating a signal like this, right? Like there's a difference between one that initializes with that value and one that updates with that value. Okay, so yeah, funny. I have so much on this topic. Like I have like 2 more articles. Anyway, let's keep on going. So here's the thing in kind of a nutshell, right? Signals, stores, memos, this. I love these graphs, by the way. This is how I do all my development, like space planning. Like I use these for everything. This is how I created Solid in the first place. I think I showed that on a previous stream. Yeah. What was it? What every framework could learn from React. Now that one doesn't have it. Doesn't have the same. This is clearly not my most popular article. Okay. Uh, yeah. The whole article is about is about me recognizing basically on a quadrant graph that there was an open space that hadn't been explored. Anyway, in case you're looking for some read from what I thought 5 years ago, let's continue now. But the thing is clear. Like on a Mutable side, on the source side, you have signals, and on the derived side, you have memos or computeds. On the source side for mutables, you have stores, but there's nothing on the derived side, right? So, first couple things, you could obviously pass values through, right? You can always derive a store from another store, by putting getters in. But like this, changing the shape here is actually kind of awkward. Do you know what I mean? You could use like a memo to like project an object that wraps getters over stores and kind of create a shape, right? But the fundamental problem here is these are all derivations are based on like calling a single function. So how do you possibly like it merges things? How do you possibly like let things fork out if essentially you're calling a function and returning a value? It's like by its very shape, it's a merger, right? And I read this whole thing, incremental computeds from Signia. We talked about this a bit on stream, but like Signia is clearly built for React because like if you look at this really cool example, which is, as I said, complicated, and we covered this a bit on stream already, but they came up with something that's very similar to map array in Solid, where they, if you could make it by hand by making this map function by using a computed and then basically handling diff like operation equals add, replace, remove, handling diff operations to produce the next data and more diffs for the next thing down the line. So if you pass the diff all the way through, it lets you do stuff like map over a list of names and then for each one split and reverse the name, like basically reverse the letters. And what they showed is that there's 5 items in the list, and when you call, and then it calls, you basically you have 5, right? Because it called this map function callback 5 times. Now, if we push a new name onto the list, you can see that the results reverse the name, but they only called it one more time because they were able to use this diffing logic to only apply the specific patches. So this is pretty powerful, right? They changed the first person's name to Sunil. Again, only one more run. They pop something, and guess what? They realized they didn't actually have to map anything again. So the map function isn't called. The list just gets shorter. So this is powerful stuff. But what you notice about it in this example is the source list is still like they're using Immer to do fine-grained updates, essentially. This is what they're using here. But under the hood, it's actually creating a new array every time. This is a mutable change. They're just doing a smart diff with it. But the problem is they're still cloning the array every time. They're still doing all the work. And while they're saving on the payout, which is great, they're not like, this assumes that the array is not a store or a proxy. It just assumes that it's always going to be this big chunk of an array. And I mean, there's nothing wrong with that per se, but every single step of the derivation has to pass the diff along to benefit from it. You pay the cost of the whole chain. In some cases, fresh data from server, there's no stable references. Something needs a key, the models too, you know, which is what React does. Immer doesn't, so it was kind of obvious. And what I ended up with is this silly meme, but it's true. Sometimes, like, it's not hard to write code that would just update the store in an effect. Like, we're trying so hard to derive it, to not break the chain, to keep things, you know, consistent, you know, for async considerations and all this. But like, compare this to get this, you know, whole thing versus literally just using a store and going create effect, add the reverse name to the store. Like, you basically in a 2-liner accomplish all of this. Don't have to diff all the way down the line. It's just the one element updates, like we showed earlier, where the one piece updates in the DOM or whatever. You saved like this whole thing, writing all this custom code, doing all this by doing the wrong thing. Right? Like, everyone knows you shouldn't use effects. But it's like, the correct solution is so much harder. So we, like, it's just like, it was really frustrating because like I couldn't accept that this was the best we had, especially because this is what React pushes you to. React basically tells you that this is the best you have. When you know that you kind of cheat it a little bit and just get past it. So the gist of it was I followed the shape. Right? With a signal, when you set, you know, you can basically update a to-do when it's immutable. Like, the proper way to update a to-do is you set a new object, but if you need the previous value, you can pass it in and then you clone it and say, now this was false, now this is done. This is how you update an immutable atom. But with create memo, you can also project, you know, add a new field onto it to do with priority, for example. And every time the priority changes, it will, you know, return a new one. This is how immutable changed. And what I noticed was this function, the memo function, was the same as the setter function, right? So I was like, why don't we do this with stores? If stores do this, then why don't we just make something that does this? Now, as I said, I've covered this a bit on stream before, but the key thing you have to understand is, someone asked earlier, why do you have set store, right? It's a proxy anyways. It's kind of the same thinking here. Implementation today isn't leveraging the fact, but like createWritable, we now know that the only thing that can update this projection is within the scope of the function that we pass into create projection. So while there's implementation details that I haven't worked out completely on this side, conceptually, this is an API shape where we could have enough knowledge here of not, or at least directing the graph in such a way that it won't break. Yet, with mutations, be able to granularly update the pieces, right? And similarly, how I was showing earlier, how you could have a derived signal, right, by passing a function. Why not have a derived store, like writable store, like this is the createWritable, this is the createWritable store scenario, right? By doing this, the same kind of thing, right? And this is an example where the prop forwards through, and here's an example where the prop diffs against the current version. We'll talk about diffing in a bit, because it still exists in this reality. But the more important part here to understand is that, like, if we kind of follow the chain here by following the shape, we have the potential of unlocking that fourth quadrant. And you've probably already done this before, to be fair. You've used projections every day, if you've used modern frameworks. I do admit that projections might not be the most obvious thing because they're a function still, it's really weird to have them do all the same work every time. Like, for example, if you had a to-do with priority and listen to these three, like when you update done, done gets updated, then it resets all the values. Maybe these haven't changed, so like nothing gets notified, but it does rerun this effect. You are still converging, at least at this point, even if you diverge after, like if all of these update downstream independently. So this isn't amazing, and honestly, as this gets nested, you're probably not going to just do this, right? I use the Trello demo that I showed before as an example here, where basically we use this as a way to apply fine-grained updates, like from optimistic updates, like one at a time. And then when the fresh data comes from the server, reconcile it, diff it, right? I talked about the Trello demo in a previous stream. I'm not going to get too much in detail, but instead of using effects, this is a much more streamlined version of this. But yeah, I mean, if you think about it, a for loop in a framework that passes an index is an example of a projection. You have some data, some rows that does not have an index on it per se. Like, I guess technically speaking, the array has an index on it, but like if in this example, this is actually like a signal, let's say, like a single signal. It's not fine-grained. You're projecting. It's not like a store. You're actually you can project you're projecting the index onto each row. Similarly here, we can use this as a way of projecting selected state. The JS framework benchmark, we have create selector in Solid. We can implement this using a projection. Basically, the idea is you get a selected ID and you assign it to an object. And then essentially you can toggle the object between undefined and not, and only the single row will update. I showed this previously because I'd been working on benchmarking it, and while this is technically slightly slower than create selector, when I benchmarked it, it was so close that I don't think that we actually need create selector anymore. It all compresses them down into the same thing, right? Because now instead of like updating, if you've done something like this in React, like if you update the selected ID row and you check it against the row ID and do it every single row, you're going to check in 1,000 rows. This check causes it only to flicker 2 things in the projection, which only causes 2 rows to update. Why is it slower? It uses a store. The thing is, create selector was so hyper optimized for this one use case that it actually didn't even use the reactive system. It like reversed onto the reactive system. I came up with like a completely custom way to do it. Instead of tracking dependencies, it would actually call the computeds directly itself. It was a very, very specific performance hack, whereas this is a general solution. So yeah, I would say that's the slight difference. It's funny because the selection benchmark is very harsh. It's like 6 times X slowdown. So it's like it's one of the quickest operations on the whole benchmark. So it's like any variation is amplified. So like it shows the test came out as like slightly slower, like maybe 2 milliseconds, but that's at 16 times slowdown. So like, yeah, it is a trade-off, but it completely removed the need for a specialized hack. Anyway, the whole point of this is that I think we've always viewed mutability as like a bad thing, but it's actually a pillar of reactivity. It's something that you can't really do with compilers or coarse grained. Like it doesn't work. And the bigger thing for me is this really, and we'll get into this in a second. I'm now viewing things as mutable and immutable reactivity. Before, everything was basically, immutable reactivity or nested immutable reactivity. I didn't view mutable as its own category. But signals and stores are not the same thing. Neither are memos and projections. So like, even if we could unify the API, like even if we could like say, oh, all signals, you know, when they become objects become stores, I don't know that we should, right? Like, I got here by following the shape. So different libraries have different shapes. Like obviously, like if you're using ruins with Svelte, you don't have the setter functions, and if you're using view, you don't have the dot value. So like, I actually got here specifically because the function shape of solid let me kind of do the same exercise that Understalls did, you know, so many years ago. And like, there's more to explore here, but you know, I showed this on stream previously. Like, I've implemented a very basic version of this. So like, you know, we can play with it, and I've actually done a bunch of bug fixing, right? So let's take a quick pause. I want to see if people are awake, because I have more immutable stuff I want to dump on you guys here in a second, because I wrote that a couple weeks ago. As you can imagine, actually, gotta love all the authentication these days. There's a lot more. Yeah, I know this is a deep topic. I should have warned people more. Like this article, this is probably the most cutting edge stuff. And there has been exploration here in the past. MobX state tree is one of the most like furthest in this zone. I don't think they've quite gone in a certain direction, because like React is what they were feeding into. But there's a lot of pieces, especially when we get into the details, that MobX, Immer, like Michelle Westert has honestly like shown the way. We are lucky on that side. Maybe not on the framework rendering side. I'm trying to bridge that gap, but there's a lot of prior work here for the stuff that I want to talk about next. Funny how when it's boiled down to, well, that's the funny thing, right? Like, I think we all understand that reactivity is mutable, right? Like, even though the cells are immutable, like the difference between immutable and mutable stuff all comes down to the source of like that change, right? Because if you think about it, what makes reactive systems mutable is if you have structures of mutable of these immutable atoms. Because once you form them to structures that can change and references that stay, it's no longer immutable. But like, that's why you use these technologies in the first place. So like, it doesn't, like, if all we were doing was, I mean, maybe not. Like, as I said, Signia looks like it was built for React, essentially. They're trying to give React as much knowledge as possible to push the diffs down the line. But if you build with a different thing that you think that you could get the mutability all the way down to the DOM, it completely changes your perspective on what's important and so on. Could be on a flight again soon. Lovely. Yeah, I'm not on the 288 flow camp at all. Because Ryan always changes streams. I love that sarcasm. Okay. So people are still alive out there. I'm glad to hear that. I'm sorry this is a lot, but hopefully some of you find this valuable. One thing that sucks about streaming to Twitter right now is I can't actually see the accurate count of live viewers from the other platform. They all get combined. So like when I go into Twitch, I can see, and our Twitch numbers are down a bit, but I can't tell my YouTube numbers. I guess if I went to YouTube, I could see our live YouTube numbers. It's a good time also for people to to subscribe or whatnot. Another reminder, follow the channel, hit like, greatly appreciated. Yeah. We have much higher on YouTube. I think streaming to Twitch or streaming to Twitter hurt Twitch more than the other ones. But yeah, Twitter's like this like counter that just keeps on going up. All right. Yeah, this ratio is not good enough. We have 115 concurrent viewers and only 51 likes. So that's on YouTube. We have another 30 or so viewers on Twitch and another, I don't know how many are on Twitter right now live, but let's get those numbers up. Oh, 2 less people watching. But we got 4 more likes. I appreciate you. Thank you. All right, let's continue. Okay, so let's share this to the stream and we're going to talk about the next topic. So the first place that I went to when I started thinking more about this mutable reactivity was like array operations, because everyone can picture how you update an object and it's all fine grained. It's like really easy to picture how like it's the like the two MVC sorry, I'm trying to think of how to phrase this. Like, it's very easy to picture how you can have a signal update one place in the DOM. And when you have objects and stuff, it's not hard to picture, like, you update the name, in the user, how it could, update the one place. But when you start dealing with arrays and structural stuff, you start going, okay, well, if I have granular reactivity on my side, can I do better than all these, like, diffs and map functions and stuff that, we tend to use, right? So I started looking at array operators really basically, and I was like, interestingly enough, like you can kind of split them between immutable and mutable operations. And there's some new ones I'm not going to be aware of. I don't know if you guys are aware with. It's literally a shortcut way of assigning one index with an array and returning a clone. Probably the most inoptimal operator ever, but it exists. But yeah, map, flat map, filter, reduce, slice, with two splice two thing. For each is technically not like either or, but I'm gonna put on the mutable side because for each gets you to like it doesn't map, it doesn't return a new array. So then obviously pop, push, shift, unshift, assigning it an index, splice, sort, reverse. It's interesting that now there's like 2 spliced, 2 sorted, 2 reversed. So I was just like, okay. And there's a couple things that you kind of like realize right away when you're looking at this, right? It's possible to clone any data and then mutate it to perform an immutable action, essentially. So in a sense, immutable actions are a superset of mutable ones from a certain perspective, because like if I wanted to add something in the middle of an array, I could use, I could probably find a way of like using reduce to do it, but I could also just clone the array and then splice it in, right? But on the other hand, reduce could also be used to implement every single immutable operation, right? You can, not these ones necessarily, but these ones, right? You can implement map or filter with reduce if you want to. It isn't always the most optimal to do a O to N operation, but as a baseline, you can. In general, all immutable operations are O to N, but with varying costs. The benefit of mutable is that it can be O of 1, right? In terms of like big O, efficiency. But what does any of this have to do with reactivity? Well, someone in the Solid Discord asked like what was the best way to map or filter a store, and I was like, I started like kind of wondering, I'm like, does mutable reactivity actually change anything here, right? So let's do a little bit of exploration here, if you'll stay with me. But I'm going to start with map function because it's basically what all UI rendering is. If you think about it, UI equals a function of state. It's a map function at its core. So or create memo or computeds, they're essentially map functions. Create projection is actually more like for each, just kind of a side note. But mapping at its heart is immutable. But we can map over mutable data. One of the benefits of doing so is we can update it independently of the map running. If your data is immutable, the only way you can update the value is to update the source and remap it, right? So this is kind of like a classic example. Let's pretend you have like an array that you're going to double, right? You can map over it, call your doubler function, and then when you update the array later, you'll clone it, add this at the end, and then run over it again. This is just Immutable 101. One thing I will say is my preference is not create mutable as it is in Solid today. I'd rather our like explicit setter version of mutable be used. Right now you have to use the produce function, so it's not as convenient, but I am not like the biggest benefit of Solid's create mutable today is that it can like invisibly sneak its way into existing APIs that aren't expecting to be observed. But I feel like that's a special case. It's a dangerous thing to just like put proxies into intercept stuff. I think there's probably better patterns. Like it makes a lot of assumptions about how the library that you're sneaking it into handles their data. But in general, yes, mutate. I mean, all our stores technically are immutable, even if they have like an immutable interface on the outside, they do mutate the underlying data, which is more efficient from update standpoint and in terms of notifying change, right? Only the one thing needs to update. But obviously, like when you do immutable data, I made the same example reactive just for the case of like showing it, right? Create signal, create memo, array map doubler, and then I copied it. And what the reason I did this is I'm just trying to show that like I might write something like this, but in my head, I'm picturing like a setter essentially. But fundamentally the same thing's happening, right? You create an array, you map over it, creating another array, which gets stored here. Later on, you clone that array, which triggers this again, which maps over, creates another array and stores in, right? Right. Whenever we add a new item, we clone the array with the new item, we map over all the items of the array to produce another array. This example allocates 4 arrays by the time we're done. Now, conceptually, we could remove one of these allocations by not cloning on write, right? Like a lot of people, when they're in their frameworks, they'll do something like this. They'll push, and then like still tell it to trigger. This is like the old Svelte, like push to the array and then assign the array kind of mentality. Or even in React, people do this a little bit. They'll like push and then set, and React doesn't necessarily do equality checks on simple stuff. Like generally speaking, hooks actually got people thinking about this more. Back in the class component days, the referential equality wasn't really something that we talked about at all, if you remember, and it's largely because of those dependency arrays. But regardless, people still do stuff like this. So there we go. We saved cloning one array. And honestly, if you remove the equality check with signals, you could do the same thing, right? We could also remove an allocation by not mapping over the array again. Essentially, instead of calling array.map the second time, we know we're only pushing an item at the end, so we can push it and then we can do this. It has us writing the code differently though, so like it doesn't work in our set array type example of reactivity, but I wanted to kind of show like the mentality switch of going from something that's immutable to something that's mutable, right? And we can also avoid allocations here by only storing the final results. We could also just say that we only have a doubled array and that we create it by doubling the values, and then when we push, we double it. Like I'm just going from our baseline essentially of like where we start when we think about like doing an immutable operation to get a doubled array, to like the mutable version, which is in a sense a lot more efficient because it's only creating a single array and it's only doing the one change. There's no more map function though. This is the most optimal way probably to write this code, but only if you care about final results. If you need the array somewhere else, then you need the intermediate. And the other thing you should note is there's no history, there's no previous value. We don't need it here, but you kind of need explicit knowledge at all points. Like the difference with this is if you called, say, like set array in two different event handlers, the logic of how to handle the stuff is encoded into the graph, where, you could push something here, or sorry, add an item, you could remove an item. There's all these different operations. Here we've gotten very, very specific, where we know we're doing a push, So like these are not equivalent. I mean, what do you mean proxy won't be considered? I mean, I'm proxies can be immutable. I mean, sorry, I'm missing something here because we've literally been talking about proxies in terms of stores this whole time. I'm just establishing a mutable change. Proxies can be immutable. If proxies are immutable, then we're not gaining anything though, because nothing changes. There's no value to the interception, right? Like if proxy is immutable, then its value doesn't change, which means we're not tracking anything. I don't think I quite understand. Okay. So anyways, where is it going? Instead of describing the final output, we're describing the necessary changes to get that output, right? This is actually less declarative if you think about it, right? Okay. Often you need to do intermediate value anyways. It's applied to other computations, recalculate need history, provide information about what has changed, right? What I was kind of getting at is this, like technically when you write it this way, you literally can pass any operation here and you don't care, it still works. Whereas if we were trying to do that like with a completely mutable example, let's say we're using create projection to project out our store, we'd have to have custom logic inside our projection to know what to do. Like say when the array length got longer, we'd have to know to push on the new element. Like this example could handle our specific doubler case, right? We could set the array, we could, push on the one value and then trigger this projection, which then would check and say, oh, there's only one more value. I need a process. And this is perfectly fine-grained. It's basically the equivalent of what I was showing, here with reactivity. But if you weren't doing a push, if you were doing a removal, you'd need different logic here to handle the different cases, right? Basically, it'd be safe to say you basically need a diff to apply derived mutable updates. So is this any different than being immutable, right? Because like if you're going to bother like pushing a diff through, then what are we doing? I think the only difference is that diffing has a potential stopping here. Any additional changes or derivations would only need to apply to the relevant part of the data rather than the whole thing. If only one index in our array updates, we don't need to notify things that depend on the other. We forked the reactivity stream, right? So what I'm getting at is the one benefit here is after we handle the diff at this point, or like the specific set of changes, anything listening to doubled array could independently be notified, essentially. Like it doesn't need the diff to transfer further down. Oh yeah. Sorry, that's implied. I'm already like that's the Solid 2.0 API essentially, right? I mean, I guess you don't need a setter. The one reason that I was looking at a setter instead of a mutable versus a mutable store is that the untrackability. you don't want the settable to, like, there's still a value to having the set start at point of time. If you had a settable proxy, you could actually split it up and like pass part of it down, and you start getting the same classic immutable versus immutable problems on the setting side. I think it's actually important to have a singular function or singular entry point. Anyway, so I kind of keep going. Templating is a map function, right? Basically like JSX. Like when you look at a component, it's a map function. You put data in and you get JSX out, right? So this kind of got me thinking about like control flow in UI frameworks, right? Solid's weird in that, in my perspective, we have 4 different control flow components, and most JS frameworks don't. Most JS frameworks have like 1 or like 1 with 2 modes. But Solid itself ships with 2, and then Solid Primitives has a few others, but like 2 of them are important for me. I pulled out my four graph again, and you kind of see this, right? Immutable versus mutable, keyed versus non-keyed, and kind of, I'm gonna, zoom this a little bit less so I can get it all in one page. In Solid, these are the names of the operation, but I identified that for optimal operation, there are 4 different types of map functions for UI. Yeah, although there's a third dimension for its immutable and immutable of the data inside the array. Maybe. I actually talk about each of these as applied to mutable and immutable data, and my assumption in that is that because being immutable is being immutable, there isn't actually that much difference, like, because it has to be immutable all the way down, and then once you're mutable, then like all bets are off. So I'm not actually sure that's true. Yeah, I mean, I do talk about each of these methods if you try to apply the other one. Like if you are talking about something best for keyed immutable and you use mutable data, I do talk about that in this explanation here. But generally speaking, each one is kind of optimized for their space. So I'm gonna go clockwise around here, starting from here, and we'll go through all 4 really briefly, because I think this is actually really relevant when even talking about how other JavaScript frameworks work, because key by index is actually the default in almost every JavaScript framework, which is like, in React, it looks like a map function with no key. In Svelte, it looks like each with no key. In Vue, it's very similar. In Solid, it looks like this index component here. And the thing to understand with the key by index or non-keyed is essentially if you render some data and create some DOM rows. So these rows are the DOM, and this is like the data thing. Initially, the data is associated with the row in the DOM. But then if we say shift, so like remove the first item in the list, what a non-keyed or key by indexed approach will do is it will remove the last element in the array, like the last DOM row, and then it will shift up the data. So the thing that was item 2 is now associated with the DOM in item, the thing that was item 2, which is, I guess, the 3rd row here, ends up here. This one ends up here, essentially, because you remove the first items. You remove this item, and then these just shift up and they get rid of the extra DOM element. This is, as I said, the most common, and basically every framework ships this as the default. Interestingly enough, this is not the default in Solid. We don't usually tell people to use index, but this is probably the most common thing to do. In VDOM frameworks, they tend to iterate over the whole list, running all callbacks, and then match up index with the DOM elements when applying the changes. In reactive frameworks, we tend to cache the map rows and update the row data at the index it has changed. In Solid Particular, it's clear what's going on here, as the index is constant and the item is a signal. This is kind of an interesting thing from our API. You can see this, that in Solids, you can actually see that the item is a signal that can change and the row is constant. Because if you think about it, when you map over the function the first time, or when you add a row, that's the only time that callback function is called. So this index can never change in the DOM. See, blue, green, green. Whether you add or remove rows, it'll always stay the same. However, the item associated with that row can change. So that's a key, even though it's kind of like backwards thinking of this compared to React's approach, that is effectively what happens when you key by index. Everyone following so far? This is like what happens if you forget to put the key in your Svelte or React component. With immutable data, when dealing with immutable data, the list is always updated on any change anyways, which means this map function will always run on any change. The entries at any updated row are new references. This means that items that aren't changed versus the previous index don't need to be updated. However, something like our shift operation, while not actually creating any new references, moves the position of the array, causing all equality checks to fail. Moving items as new items with this approach, which makes it less optimal for these sorts of operations. What I'm getting at here is, like in Solid, and technically, I guess, in React or whoever uses it, when you do this operation of shifting, you actually have to go in and look and go, oh, I need to update all the data associated with this DOM element now. Because before, name was John, now name is James. Before ID was 1, and now ID is 2. Like, basically, when you shift it up, like there are operations like changing in place where these aren't affected, but say like a shift is a good example. We actually end up updating all the rows with our immutable data, because with immutable data, even the like if you want to change the name of a user, you need to clone the whole array, which means that it will trigger this process. One of the benefits here is that you sometimes can save on paint. Like if there's a lot of static layout here, or like CSS styles based on like row style, this can cause less repaints because nothing moves in the DOM, just like specific data points update. But sometimes it can also be like disorienting because, visually it will look to a certain degree like you just removed the first item. But from work standpoint, like if something was expanded if something was expanded in this row, let's pretend you had like the details opened. When you moved it to this DOM element, you actually have to re-render the expanded part, like actually create the DOM elements again when you shifted the data up, and actually remove this expanded part when this one isn't expanded as it shifts up. Which kind of gets at the problem, which I'll talk about in the next section, but just something to be aware of why someone might want to use immutable data. The other one with, and then with mutable data using index, we don't need to recreate the array if something nested updates, right? So we don't always need to run the map function. Only array operations that would add or remove items would trigger it. However, in those cases, since moving the items are seen as new, it isn't particularly efficient way to do these type of mutable data. Yeah, like because moving stuff around is always seen as new. Like basically the one place where this is fairly efficient is that like if the item hasn't moved, you can just like skip these and just update the one row. But with mutable, you don't even trigger the whole array thing, because if you're updating a name on a user, it doesn't actually trigger the array process. So the only operations that are left to do are like the moves. So this is like generally just not a good thing for like mutable data. Because it's basically, it doesn't get any of the benefits, and it's just the few places that it actually triggers, it's less efficient. Joe Pia likes createMutable specifically. He didn't like the API shape of solid stores, but technically speaking, our stores have always been mutable and we've always had them. So yeah, he just liked the idea of being able to mutate stuff everywhere, and no amount of like, as much as like I'm talking about these APIs and talking about like none of this changes my principles here. I'm still not a big fan of being able to mutate everywhere, so to speak. Yeah, it's pizza pants up. Well, I haven't even got to what Solid's doing yet. Right. But yeah, so you kind of follow along. So key takeaways with key by index or non-keyed. Item data can change, but index is constant. Best suited for immutable data, as any change would cause re-execution anyways. Best suited if the row data doesn't move or is removed, or if it can't establish an identity, i.e. a primitive value. I'll show an example why in a minute. Not recommended outside of suitable cases, but sometimes can be performance boost by saving repaints. On projections, projections are a derived store, essentially. They're a mechanism for doing derivations dynamically on nested fine-grained reactive data structures. Anyways, so explicitly keyed, this is like when you add the key prop on your component, does this. Now when we remove row 0 actually gets removed. So in a sense, these might shift up in the DOM, but the same data is associated with the same row. So like if this is expanded and you remove this, well, this is still expanded. Like you didn't have to render any new DOM elements, you didn't have to change anything. This keeps the data with its row. Oh yeah, we literally just spent an hour with that article. I mean, we'll talk about it more throughout the stream, but yeah, I'm the key part about it is stores are mutable reactivity can be very efficient. It gives the ability to kind of split the reactive graph again, and we're missing a way of doing it in a derived way, which is what we've been working on. Slightly off topic, as templates are a map function, is it always necessary to convert data types to an array? Well, no, I mean I just mean like a map function in general, like input in thing out. Not necessarily like an array map function. I just mean a map callback function. When working with method, would it be okay to make an array that we can use DOM directly, or does that break reactive rendering or deeper content? No, I mean you could definitely support those kind of data structures if it makes sense. The biggest challenge is, see, what's nice about order is what ties these things together. Like why I'm showing all these, like I love using or shift because it shows where things get messy is when you mess with the order of things. Anyways, keyed is the recommended approach for most frameworks. Many have warnings in their docs or even development environments. If you use a map without a key, they'll be like, you should be using a key. Everyone's seen that error in React. The idea here is that the same row of data is always associated with the same UI element, that when you shift a row, the first DOM element is removed and the others stay unchanged. The key thing here is while we pretend UI is a function state, the DOM is stateful itself with form state, focus state, web component state, CSS transitions. So using non-keyed approaches can have severely detrimental side effects if you're moving elements around. You can read more about it here. Yeah. This is a classic from the JS framework benchmark author, Stefan Cross, but I'm going to link this one here for thing, but he talks about this, but he was showing that the difference between keyed and non-keyed is he highlighted a green and then he deleted it. But then he's showing that like if he highlighted here and then he added, like replaced the row, like essentially because of like, here's another one where he has an animation. Is it the animation? Yeah, he's talking about this X. See, it grow. He has that weird animation where it grows and then deletes, and he's showing that it deletes and then it shrinks back down on the new element that wasn't being deleted. See, it switches to 3 midway, where this one, when it gets to the full size, deletes. Gone, right? It's basically the inherited element when you're non-keyed adopted the state of the DOM. And this is the biggest reason why everyone frowns on non-keyed. I give an example about the expansion stuff. Basically, you should almost always avoid non-keyed approaches if you're like if there's like basically any kind of chance of preserving state in the DOM. And usually it's better when you have things like models, things that are like objects that you're mapping over, like non-primitive values. Anyways, key showed it in, you can do it like this in React and Svelte. You add this parentheses. In Solid, there's a primitive, which you can go like key by ID, does a similar thing. But again, you only use key where it makes sense, where it establishes an identity. For example, if you had a list of strings and you had an input, that this is React code here, that you basically updated the list. See, I used with, but essentially with whatever's currently in the input. Can you guys picture what would happen if you're keyed by item, and every time you type a character, you set the key again? Well, this here is a good way of making janky UI. Is you can also make janky UI if you key by a primitive value and then have like an input that that sets the key. Yeah, the input re-renders every time. So but it's an input. So what happens when it re-renders every time? Well, it loses focus, right? Like, it's possible in a simple case that like React will be able to tell that it's the same element or something, but generally speaking, this is a very good way of like unmounting and mounting an input element and losing focus while you're typing like each character. I've had reports like this before. It's pretty funny. This is a case where it doesn't make sense to the key. If literally all you have is strings. Anyway, if all you have is strings in an array, it doesn't make sense to use a keyed thing. This is like the one exception, right? Anyways, as with non-keyed, any change will lead to this routine running, but with keys, the number of map callback signals you need to update can reduce. This might be more obvious with signals, as moving a row only requires an index change if the row isn't listening. Yeah, one of the things that might be interesting here is if you notice in the solid version, both the index and the item have the potential of changing. They're both signals, unlike with the previous one, right? One benefit is that when references are completely lost, like fresh data from the server, this approach has a key to match it on. So while row callback and signals all update if the server changed, also moved rows around the overall differences in values should be kept minimal. Yeah. Yeah, it's interesting. This is basically a shallow diff for all intents and purposes. So there is some value there because it actually is diffing against something explicit. With mutable data, again, nested updates don't require this routine to run. But for the, so if you update like the name on a user, then it's not going to run this. But, for other changes, this is pretty good because you don't lose references. Like if the key is the same, it stays with the DOM. You don't have to worry about re-rendering. So this is a pretty good choice for mutable data. Be mutable in nature, the item with the same identity have the same references, so the extra check only beneficial if the reference is somehow lost, maybe fresh data from the server. But for that to happen, then all downstream reactivity needed to be replaced, basically state you never want to be in. So the one downside of using keyed for mutable data is in any situation in which the key would match, but the reference wouldn't, like you have a different object, you would have had to recreate all the reactivity, like nested reactivity for that object anyways. So it's not really a place you want to be at. Basically what I'm saying is, while this is better than non-keyed, for mutable data, if you think about it, it doesn't even need an ID because the references are stable. You don't want to recreate all the nested signals, essentially. So you, like, it doesn't make sense to need a key. Reactives immediately keep the old values and make a current rendering sense. How does mutating the values not cause issues with solid suspense? Well, we use the same trick. Every signal is immutable, so we do keep the previous value around. We just do it at a hyper granular level. So essentially, instead of like they're like, look, we have the old value of like, and we have that previous value already anyway, because every signal has, you know, the ability to have the previous value kind of passed in. So we just, instead of like having like the previous tree or whatever, we just have the previous version of every single signal on the page. So we actually like fork the graph essentially, and then merge it back together. It's almost the exact same concept, except it's done at a more granular level. It's like done at a data level instead of like a component tree level. Anyway. I doing it with stores was a little bit more tricky, but it essentially is the same idea. So takeaway, item data and index can change. Best suited for immutable data, as any change would cause re-execution anyways. Best suited for most non-primitive situations. So this is a good thing. And to be fair, now we're done. Most frameworks, even Svelte 5, I believe, this is all they ship with. Solid has two more mapping functions. First, we have for, which is our primary one. This is our default one. This is the one that we tell everyone to use essentially, which is actually in the mutable keyed side. So I don't have anyone else to show for this because this, to my knowledge, doesn't exist in any other framework. It probably does by now, but but in terms of the major frameworks, they don't have this control flow. What I started realizing is that mutable is mostly an optimization here. This method works very similar to explicit keys, but relies on the fact that nested reactivity keeps references. And so you can see the index is the signal, but the items is constant. This approach, so if you try and use for with immutable data, it works very similar to having explicit keys. Any change will cause the item reference to no longer match, so it recreates it. The one gap here is if you lose references, there's no explicit key to fall back on. So this isn't great for data coming from the server. And, you know, it will always recreate rows. So like it's not amazing for immutable data because essentially it's less granular. If it's mutable and you update a name, you don't need to rerun the row. Here with immutable data, it won't rerun the other rows, but it'll rerun that row, which makes it worse than say keyed with signals, because with keyed with signals, you just pass the new data. You don't rerun the callback function. You just pass in the new data. So it'll only update those locations. With for, item is not a signal, only index is a signal. You start. This is actually kind of a funny comparison as you go around the table, because we started with index, where index was a constant and item was a signal. Then we went to keyed, where they're both signals, and now we're at for, which is the opposite, where index is a signal, the item's not a signal. It's kind of funny as we move around. But yes, this is not actually great for nested immutable data, because it actually would recreate the row essentially were you to set a new object completely. It's not terrible for simple things, but it's not actually the most optimal approach for immutable data. For mutable data, this is similar to keyed, except it removes any unnecessary signal wrappers. It has the slimmest syntax so far, so you don't have to worry about keys. In cases where the row doesn't depend on an index, no rows or signals are needed to be updated on any change from the perspective of the map function. Yeah. So think about it. If you don't use the index, here. And this is why if you see Solid's map array, we don't actually create these signals if you don't pass this, like take a second argument. We don't actually need to create any per row like signals for this operation. The only thing that this does with mutable data is just move the rows around. And if you don't care about where it moves to, we don't have to update any signals. It's just a way of telling the DOM, like, okay, move this row here, move this here. All the updates per row are completely fine-grained. They won't even trigger the map function. This is part of what makes this so powerful, right? If you always assumed immutable data, you would never make this component. But with mutable data, this doesn't need to even run most of the time. It's add, remove, move operations. If you update anything else, nothing else needs to update. And even with those move operations, you don't even need to like update anything in here, which is super powerful. So item data is constant, but index can change. Best suited for mutable data changes as it removes unnecessary overhead. Best suited for non-primitive situations. Okay. Right. And then it's the last one. I originally wrote this a few years ago. I was making a 3D demo. You guys might have seen this one before. And I came across this this problem. Anyone seen this demo before? The idea is you could like bring up the number of blocks to like the craziness, and you could still have super good performance in some frameworks, not in others. And this was originally a demo to show off how good React concurrency was, but then Svelte came out and actually absolutely demolished it. And then the Solid version came out and absolutely demolished Svelte. And but anyway. Yeah. Yeah, like this is getting locked on my screen, like my screen FPS. Like, anyway. The key for this was I designed a new control flow component. No, this was before Million was created. This was like, this is the reason I joined Twitter. It's funny because I just signed on to like Blue Sky for the first time in like over a year just to check it out today. But I was kind of dragging my feet. Twitter, I didn't join Twitter until like 2020, essentially. Like it was like December 2019. And it was because someone had built this demo and they're like, show Solid's the fastest. So that's what I did. And yeah, so this is a couple years before Million. Yeah, this is my screen sync rate that's keeping it at 120. What I was getting at, it's the you know how like it's odd that like I think it's my screen, unless we set like maybe we set a limit in here somewhere. I can't remember. But yeah, 98 is not going to be the same as, like, we don't drop off 120 until we're at about 3,500 blocks. So you'd think these would be way faster. But even at 10,000, we're still at 40 FPS here. Yeah, vsync, yeah, exactly. Yeah, I think Svelte 5 would probably be a lot faster now. Yeah. You might even want to look at Rich's original implementation, because he did a really great one there too, which inspired this one, to be fair. But yeah, let me share this. To be fair, this isn't using, the key part about this is not using Solid. This is using TWiJ, but this is not using Solid 3. This is built, like, this is a joke. This is not actual Solid 3. This is like this is like, what could we write in 70 lines, right? Like this, there's actually a solid 3 library. Yeah. So anyways, it's not that important. The key for me was this actually was where I first implemented the first repeat operator, which is different. It's funny. Vue has a repeat operator, and Knockout did too, but it doesn't work like this. Yeah. Yeah, I think that's one of this is actually a really good point. I think this was one of the cool things about like the abstraction. It was really easy for us to do these kind of experiments early days because like in Solid, like unless you use lowercase tags, you're not actually using any DOM APIs. So like you could build these abstractions even before we had the universal render really trivially because we had no real concept of components. They're just like functions. So like you could just like do whatever you want in the function and then like ta-da, component, you know. So it made these demos work really easy. Oh, I'm funded by, I'm very proud to say this. I'm funded by Sentry. And previously I worked at Netlify. Both companies have helped me. They actually hired me with the knowledge that I would be working on this stuff full time. That was like that was the plan. So, yeah, I've been one of the few people fortunate enough to get paid to work on what I work on. Anyway, how does repeat work? It just puts a count in on the length. And it kind of something occurred to me a while back that this is kind of the craziest thing about non-keyed with mutable data is it turns back into basically the object like fine-grained thing. I don't know if you'd want to do here, but if you think about it, this doesn't even take the list because it's keyed by index. It's not keyed by the list. So it doesn't need anything. There's no references. It doesn't need the list. And there, and what it does is it returns a constant, right? So this just repeats the thing. And for a lot of times people just don't even do this. They just like, they don't need the index because like it doesn't matter. And they just repeat the item like 1,000 times. But the key here is how this works. With immutable data, this control flow feels like you could just replace index, right? But there's one important difference. Without nested reactivity proxies, the above looks more like this. See how we're calling a function here for the list? And the problem with this is whenever you update the list and it's immutable, you have to literally update every single row, right? So while it's like convenient that like as you add the rows, it just fills them in and then you remove them, you know, it just removes them. And if you move them, it just, you know, essentially moves the data around because this is the data. It's whatever you access. It doesn't need to even pass it through. The problem is every change essentially causes every row to update. So this is the worst possible, probably immutable thing. The difference with index is index does a diff for you. Essentially, it's a basic diff. But if we go all the way back here, it passes you the specific items. So it knows, it only calls the rows where the item has actually changed. So if you're doing immutable data, it's like, okay, this row has changed. I'm going to update just this row. And it over updates when you shift stuff. But the difference with repeat is when you're doing immutable data, it's like hitting all of it, right? But the opposite is true. With mutable data, it doesn't need the diff at all. It doesn't need signal to be provided as the store already has one, right? The store is the signal. The index is constant. This differs from 4, where we need to project an index signal over the map. So basically, unless the length of the array changes, the map function here doesn't need to do any work. It isn't even responsible for moves. It just handles additions and removals much more optimally than using index. What I'm getting at here is, if you think about it, if you swap 2 items in the list, only those 2 items will notify here. Right? If you go replace 0 with 1, then only those two rows need to, like, it only listens to those two rows. It doesn't need to rerun the repeat. It doesn't need to rerun any of the other rows. If you update a nested item, well, then it's not even here. Something inside will update. So it's like, essentially, because this is constant, like the index doesn't change. Like if you add a row, it's just going to go, okay, run one more of the map function. If you remove a row, or remove two rows, even if it's the first row, it's just going to remove the last row and shift all of these, conceivably up, right? Because that's how non-keyed works. But what's crazy about it is you never actually need to pass a list to it. So this is a much more optimal approach, because again, it doesn't need to create any signals in the same way that this doesn't need to create any signals if you don't listen to the index, right? So it's interesting. No, I mean, Netlify didn't use Solid very much either. I mean, there's a few little things, but I've been trying to, at different points, I've been like trying to reconcile like why I get employed. And I think the work that we're doing with Solid, the stuff that we cover on the streams, is, I guess, important enough for exploring the space of what's possible. The impact that Solid's had on the wider ecosystem is much larger than our adoption numbers would show, so to speak. It's kind of a funny thing, people keep on. I've had a conversation. People are on some Reddit, and someone's like, blah blah blah, this blank, Solid no one uses, blah blah blah. But it's like, or is Solid what everyone uses? They just don't know it. Anyway. Anyway, my point is, index of constant items data isn't required. Best suited for mutable changes, as is inefficient for immutable data. Best suited if the row data doesn't move or is removed, or if it can't establish the primitive. Not recommended outside of suitable case. Basically, all the things about index are true. This is just, like, for mutable data, much more optimal. So, concluding thoughts on this control flow. It might be awkward that there are 4 different methods. This is only increased by the fact that, in terms of algorithmic efficiency, favors mutable and non-keyed, generally speaking. Like, this is definitely the cheapest, right? It's possible to combine all but repeat realistically into the same syntax with configuration, but does that reduce cognitive overhead? It also begs the question, are all operations equally split, like 4 different ways? Like if we have this graph, where we have mutable versus mutable, will we have 4 different versions of filter or reduce? Like, will we have one best for keying, or like, is there going to be something similar in the other operators? It's an interesting question. Yeah, I guess that's the thing. Signals in Angular, yeah, and many great people on the Angular team. So again, I hope you guys are still with me. I'm going to continue, because I started kind of looking at other stuff, and I was like, well, let's do reduce, because reduce is like the super operator. So I started the same way that I started with map, where I'm like, okay, what if we have a sum accumulator, right? And then we take an array, and I started trying to do that same thing of where we reduced it from a immutable thing to a mutable thing in a generic way, and I had to stop almost immediately. There's a huge problem with reduce, and it's this accumulator, because suddenly you like obviously with sum we can solve this specifically. Maybe if we could like have a way of reversing things, like with the like obviously with the push, it's very easy to like just add the last number, but you start going like, do things get weird if you like replace a number in the middle? So what did I say here? What appears to me right away is that the final value can't be calculated without running through the whole list. The accumulator suggests orders matters too. Yeah, like with map, you could always run an individual thing, but with reduce, you kind of have to run everything. Like, how do I like get the sum without having the previous sum? Like, now specifically sum operator actually being opted one could reverse or apply new ground change, but this sort of reversal isn't always possible, and it smells that we don't have a generalizable solution. We can't make the assumption about reduce in general. At minimum, we need to run all the rows after the change, since the accumulator could affect downstream calculations. But to do this, we need to store the accumulator at each step, which is fine for primitive values or immutable accumulators, but not ones that are mutated, right? What I'm saying here is like, if you wanted to start at an arbitrary place, like index, like if the change is on the second index, you don't need to run the first index if you cache the value from that accumulator and then ran everything down again. But this only works if the accumulator itself is immutable, or like a primitive value which is immutable, and if you store each row, like you have n elements in an array, you have n stored accumulators. Yeah, exactly. This is what I'm getting at. At some point, it has to sum all the results. Yes, exactly. At minimum, yeah, okay, blah, blah, blah. So you have to stop and consider what you're optimizing for at this point. Is it the iteration of the callback or the final output? The reason we care so much about mapping is because the mapping itself is expensive, but here it isn't so clear. If we're reducing to a single value, the rendering at the end isn't going to be the expensive part, but the calculation. But more expensive, but is that more expensive than holding all the sub-results in memory and immutably cloning it? Yeah. In some specifically, we can solve this. I'm just right. This is the thing, we start getting to categorizations here, right? But we also have to ask ourselves what we were actually saving. Yeah, exactly. If you're always changing the first value, then you're doing the most work because you have to reaccumulate all the way along, and you're like, at a certain point, this, like the general solution I'm thinking about is probably worse than just running it, right? This is always a risk. I think we should look at categorizing solutions. What makes map work pretty well and reduce not so well? Map is isolated one-to-one, which means that granular changes are trivial. Reduce has no such guarantees. Now, if we were mapping one-to-one, then maybe it could, but that is only a subset of potential operations, right? So I had a funny example here where I was like, what if we did like a normalization step where you took the ID of an object in an array and you accumulated it, right? This is basically mapping an array to an object, but each goes in its own lane, right? Right, and I basically showed like with our previous example where the map function, we could basically do the exact same thing that I did last time where I called the method for each array member and then when I added the new one, right? So like this is, admittedly this would only be interesting if ID changed as it's acting as the key here. That's true. If ID doesn't change, there's no real benefit to this whole thing. Otherwise, nested updates could easily take care of that. This is an example that wouldn't have the same overhead, but also the work the accumulator is doing is hardly expensive. Still, it could listen to array changes, change against the existing keys, and only assign and remove the necessary entries. So that's two examples. We have sum and normalize, where the general reduce operation would be less optimal than the specific solution. And I suspect that this would be true in most cases. The accumulator API makes optimizations hard to generalize. We've looked at this as one-to-one, like with our map function or normalize, and as many-to-one with our sum. which leaves many to many. The simplest many to many doesn't combine rows and happens to be another operator, which is filter, right? I might be passing by this one too quick, but what I'm trying to get at is it feels like there isn't something generalizable here, because every time you like get into a certain category of problem, you basically can find a more optimal solution than the general form. And again, what I'm trying to determine is how much of the solution deserves in the reactivity space, or just should we use typical mechanisms for optimizing it, like memoizing calculations and stuff? Like, should this have anything to do with reactivity? That's the question I'm asking ourselves here, right? So I looked at filter. The first optimization can be filter. It returns the same results, not to notify downstream. Mind you, that's the most trivial case for map to handle. What I mean is, like a downstream map, if it gets this a different array, the first thing it's going to do is just go through all the elements and see that they're the same and pass on. There's cost to that though, but I'm just saying it's not the most expensive thing. Another potential optimization would be to only call the callback functions impacted by reactive changes that would rerun. It's interesting because generally we don't track callbacks in our control flow operators, right? So what I'm getting at is, if I was like making like a generic reactive helper here, I wouldn't actually track this usually. It's like we track the array, like almost like in an immutable sense, but we don't actually track the like the sub statement. So does it make sense to like trigger stuff independently from this expression? If the filter condition changes, then all rows would need to re-execute. So what I'm saying is, if we changed from calculating is odd versus is even, I don't think we get any benefit. Like if this tracking could change this logic from like not equal 0 to equal 0, do you know what I mean? Like if that was what was reactively being controlled, we don't get any benefit to this tracking versus just like rerunning the whole array, because you have to rerun it anyways. So our only real value is if the individual value changes. So let's say like someone changes, 3 to 4, for example. Then in theory, we could only run that one row, right? This is only consideration with nested mutable reactive data, as immutable data would always replace the whole source anyways. That's a good point. So yeah, I mean, this, like, if a change is found, then we produced a new array and notify downstream. If nothing changed, then the optimization would be present. The problem is we're still sending down the new array in the filter operation. So like the next thing down the line isn't benefiting from this. This is a little bit different than our map case, because the map is kind of like our projection. It's spreading it out. It's kind of the end of the line. This is probably with the intention of feeding into the next thing. So like it starts asking this question. With filter, is the callback function ever the expensive part? You want to reduce downstream work. Interesting, filter always results in a whole new array updating because it's always an add or remove operation. So there is potential little to gain from optimizing filter when put against the overhead of bookkeeping. Yeah, right. Like what I'm getting at here is like, you could find ways to optimize it not notifying when like nothing's changed, but as soon as you change, you have to basically do an array operation downstream. So where can we get benefit? Unless we can communicate in a diff, right? That's really the only thing left. If we can say like, oh, we only added something to the end of the array rather than communicate the array, that's like, we're kind of doing full circle here on the Signia thing, right? Like it feels like filter is basically innately an immutable operation. What's the question? Sorry. If you know which elements changed, can't you untrack all the other elements when reducing? I don't think that gains us anything. Like, we track so that we can granularly only update the things that we need to update. So it's important that we would track everything perceptually in this case, because we'd want to know if any value changed so that we can make a decision on when to update the filter next. The tricky part is like, what you want to be able to do is basically say, no, don't run these other, like basically all you're doing here is saving running this callback in some cases. So if you have 1,000 rows, maybe you can know only to run this callback on 2 rows instead of 1,000 rows. But the thing is, if either of those results in a change, you're still going to now pass in the 98 rows down the line, which then will, be where the more expensive work is happening, I guess. Oh, the reduce operation. Sorry, I'm way behind. Well, I mean, maybe you could use generators, but what I'm getting at here is like we're talking about basically, yeah. I mean, if the tie is fixed, you could use like a kind of like generator way of pulling it through, so to speak. But I mean, it's the diffs you want to communicate in, right? Like, regardless of the mechanism of the linking, right? Generators are pull based, signals are pull based, right? Like, I don't think this actually changes all of much, right? We like, the key here is there any place to optimize? I'm not talking about optimization you're compiling. This is all runtime mechanisms here that I'm talking about. That brings us back to our map function. Our map function already does a shell diff, so we have to put that up against additionally supporting detecting changes in serialization. Like basically, we're in this zone now where we could basically have the filter communicate what's changed, but then we need something on the other side to be able to accept it. And one of the funniest things is I did a test a while back and found it didn't make a meaningful difference in the JS framework benchmark. I think this might be worth spending time in the future again, but to date, I haven't seen this work well. In the same way that adding the second map function in Sol's rendering didn't make a meaningful difference. I think I might have started this article by telling a story about how Solid used to do our map function right in the DOM. Like we didn't have for, we had a compiled for component that literally like just updated the DOM directly. And when I changed it to using for, I actually pulled it out, and then there's a separate reconcile for the DOM. And because of some of the simplifications that happened there and general overhead, it didn't actually make a difference. Solid actually got faster after I made that change. And then I tried doing stuff where I'd like put like hints from when for ran and communicate it through. So like a perfect example is like when you provide a new list, right? If no items in the list are shared, you can do a much quicker thing. You don't have to check all the items in the list, you just clear them and create them. So I was thinking, okay, well, if Solid's for component is doing a basic diff here, it would know if none of the items changed. So like in the benchmark, when you have the replace rows benchmark, we essentially could have the for communicate to the DOM like, hey, you don't have to diff here, like literally just wipe them out and replace them. And I did that change, and it didn't actually improve performance scores at all. Which is kind of crazy. Like a simple shallow diff was not significantly more expensive. Only the same things get mapped out, but it's a matter of saving iterations at shallow reference check. The only real savings here is if we could cache the map versions between filter changes, but that isn't something that feels like it can be done reasonably automatically. Maybe weak maps and off-screen. Basically, there's always going to be a cost to keeping things around unless we know we can keep it around. We can make versions that do that today, but it probably needs to be deliberate. What am I saying? Topic's large. Interesting to see mutable reactivity lead to new ways of types of optimization, but I think at least as of today, we are constantly be moving to an immutable and immutable world where there are clear locations for optimizations and others that are more specific. Coming up with general tools here is going to take some time. There's still a lot of optimization that comes on mutable reactivity, even with immutable helpers, because they don't need to run in as many places. Map is by far the most important one and handles, I imagine, the vast majority of cases. But I feel there's a couple more big realizations to have here before we get this all released. basically what I'm getting at here is like, generally speaking, the big benefits are not doing the rendering, right? So like virtualization type techniques are probably more powerful than these granular things. Like I was trying to think of if like map we need, so we hit this. I'm not sure if I will be making a optimized filter or reduce anytime soon, because it seems like each of these operations can benefit from a specific type of pattern. I suspect a lot of these could be built on top of create projection, but it's to solve specific cases or specific operations. I think this is the world that we kind of go into here, where there's always the simple immutable way, which is inefficient, and then mutable updates are all specifically optimizable based on the specific type of operation they do. That's sort of where I'm landing here. Make sense? Hopefully. Okay, got another one. You guys still with me? I know this is heavy. Because it's going away. It's going to be replaced with something else. This is the hardest problem with doing createAsync. I was hoping that we could get far enough, like in the remix sort of sense of the word, you know, where you like provide an API that's like overly simplistic that gets you like 90% of the way and like not worry about the rest until 2.0 came out, when we'd actually fill in the missing pieces. I've been trying to avoid adding back the things that I know are going away. So that's not a great answer. It's just there's going to be something equivalent, but like the 90% case should be using suspense. Maybe the 95% case should be using suspense. So it's like the biggest reason you want to use loading is so that you can basically have a mechanism for showing, like kind of like breaking out of transactions or transitions. Essentially, it's like using deferred value in React. Using it just to be like, here's my app switch statement loading error data is not the way resources were ever intended to be used. And I apologize for the API that made people think that that's the way it should work. Like create resource added these properties for different reasons, and then people were like, oh, it's React query, and it's like, no, that's not really what it should be doing. We need to expose this capability, but not for the reason that people think they want it. So it's just a bad API design. Okay. You can use create resource with a little bit of work. I mean, I ended up forwarding latest. It's arguable that I should just forward loading and bite the bullet for now. Yeah, it's visually useful to highlight stale data when using transactions, basically, right? Like like you can use suspense, but suspense unmounts. So the idea is use transactions, and then you can use is pending from the transaction to show the stale data. But there's times that the trick is with loading, you can compare you can basically flip it around to escape out of it. There are use cases for it. Yes, exactly. And I added latest back kind of begrudgingly, because again, it's also not going to be there in the same way. Let's just add loading back. It's easier, and you guys will have to slightly refactor that with 2.0. I was trying to introduce a new base with with createAsync, but I can't implement the other pieces until I have the reactive system that works properly. I mean, I can show really quickly here. What is it? SolidJS. Signals. Yeah. What I've done, and I hope I have tests showing this, createAsync, yeah, okay, is there's an is pending guard, which is because every single signal can be async in 2.0, instead of putting .latest on everything, there's an is pending guard that you can use to wrap any reactive expression. It can obviously just grab createAsync here, but it can also grab a memo, or it can grab a function that has multiple memos or multiple createAsync calls in it. So this is API wise the direction it's going. I can't do this in Solid because it's 1.0 because the async isn't transitive. Similarly, latest, whether we continue calling it latest, but it's the same idea. We can actually use latest as a way of kind of like getting out of like, you know, the paucely undefined value, right? In 2.0, createAsync, because it'll be throwing, will always, from a types perspective, be the return type. It'll always be like, even if it's like a promise of user coming in, A will always be user, non-nullable. Latest will give us a way of not suspending and getting user or undefined. Anyways, I've implemented both, actually. I did that last week now in the 2.0 thing. It's coming along quite nicely. But we probably should just add the dot loading, and for now, it's really trivial for me to add it. I was hoping we'd get things along further. Anyways. Yeah. Yeah, problem with mutable data structures is that they need to keep references, which means they must be mutated, but it means that they have to own anything passed into them, making it difficult for them to share. In basic cases, this is fine, but if you build stores over shared sources like cache, etc., that can be mutated in unexpected ways. All it takes is a nested write, maybe intended to replace, but instead merges, and suddenly you have two identical entries in a list when you're just trying to swap positions. A single store doesn't hit these sort of issues typically because we keep a weak map of objects in their proxies so they can keep store nodes in multiple locations with no penalty. A change in one location notifies changes at all. So clearly there's some powerful characteristics found here that exceed immutable data stores, but can we fix these issues while preserving them? So I don't know. Have any of you used stores in Solid and like had some weird stuff happen? I get bugs occasionally where people like are surprised that it mutates the objects that they pass into it. Like they'll initialize a store with some data, update the store, update their data separately, and then be like, what's going on? Is that anyone here? I think it's an important aspect of this topic. I don't think everyone has hit this issue. But yeah, I just want to throw it out there to chat in case someone out there has at least hit this issue. You sort arrays, which mutates in place. I mean, if you did that in a produce function, it would be fine. But yes, people can hold the thing. So there's an interesting choice to go here, right? So to me, this starts with, to ensure we don't override source data, we need to deep clone everything stores are given. That's pretty expensive, i.e. that what is initialized and everything being set. However, this means equality checks won't work in the future with its source. We can't tell if references have changed because even store internals no longer reference it. Stores have to clone and proxy. So that's an interesting one. Our clone should be structured, but we can't just use structured clone. It needs to respect or stop at nested proxies since we don't want to clone those. A setter might only work on a small part of the store, but we want to keep references for all. This means we need a custom clone mechanism. So this is a big ask, but I'm thinking about it because there seems to be this constant concern with stores that like it's mutating your data. Cloning turns. The first point has lots of consequences. When does it not matter? Fresh server data doesn't matter, as no shared references between the store and the new input is possible. But otherwise, we can't assume something set is the same as its source. You can't use a store as a previous state in an immutable structured diff, for example. Right? If you've ever tried to use, like, there's an old Redux example where it's like undo, like time travel. I had to come up with a kind of like way of producing snapshots myself and cloning it to make those kind of demos work, because generally speaking, we mutate the past with a store. So like obviously with immutable change, these like Redux and stuff will always create new objects. So generally like it's not a huge problem. But if it tries to go back to references it had in the past, we've now messed with them. We'll update properties on the object that we have, but when you add a new object later, like something that's not already in the store, it then takes over that object too. So even if you start the store with like something fresh and clean and you start setting those objects from other locations, if it's not just an update of specific properties, if it's getting a whole new reference, the store will keep that reference, and forevermore as you update it, will mutate that reference. That's just how it works. I think the first understanding, though, is, as I said, if you clone always, you no longer have referential equality checks, so you can't do immutable diffs, which is something we do with Reconcile as one of the options. So this kind of suggests that if we went down this path where we're cloning, we'd actually need two different types of operations for like diffing, right? One for diffing fresh data from the server and one for managing immutable diffs like Redux. Like basically there's two different types of diffs. There's one that is like Reconcile that kind of merges, and there's one that takes the previous state and takes the new state, diffs it, and then applies those patches into a clone. You guys get what the fundamental problem is. If you don't clone, you mutate it, like, so it's not safe anymore. From like, you have to own it, and if you clone it, you can't do like a traditional immutable diff. You can't, like, all the references are lost, right? I should drop this into chat if I haven't yet, right? On the mutable side, I could picture, like an apply diff, store, next value, current. Basically, you need three inputs. Memo is the secret here, because a memo has the previous. So you could always take the new value and the previous value and diff it and have the memo return it. So you could basically like come up with a way of like creating a set of patches and then apply the patches like in a projection, right? And what I point out right away is this is not that different than doing something with immer. But I think having the key argument is still important, so it might be worth implementing ourselves. But like, what is interesting is we could just say like, okay, if you want to do immutable diffs like Redux style, you should just go grab immer. I don't know if you guys all have seen this, but like immer patches, they have the ability to, produce with patches. And it even has the inverse patches, which is genius, which is a reversal of the patches. You can basically do a mutation on a store, like figure out what it is, and then get a list of operations and then apply those operations. They have like another apply patches. So what you could perceptually do, so you apply patches. What you could perceptually do is you don't need the produce with patches, to be fair, probably. I'm trying to think out. You can get immer to do the diff for you, to like, not from this, like, because you already have two objects. You can have immer take the object, the new object, do the diff for you, and then take the patches and apply them directly to the store, is essentially what I'm getting at. That's the one operation. The other operation is reconcile. I think this one still exists because there's still value in having something that's saying, I got arbitrary data, morph the store into that shape, right? You don't have a past. You don't like, it's not like if you're getting fresh data from the server, immutable diffs without keys aren't going to give you anything, right? Yeah, the inverse patches is genius. A moment ago when we were looking at reduce, we're like, oh, but we can't reverse it. This is very, very cool. Because you can basically collect a list of patches and their inverse and then apply them and then maybe keep on collecting the inverse, and then go back to any step through applying backwards. But what I'm getting at is I think that immutable diff might belong on the outside of stuff. I think there's still the more basic, like I get fresh data from the server, nothing matches. I need to basically morph this into that data. So I want to talk a bit about this because there is something else we have to think about if we go the cloning way. What do I say here? Operation key can help it not hijack anything, but without reference equality, shortcutting with the store owning its own sources, I see no reason why you wouldn't attempt to keep most of the references as possible. Yeah. So the idea is right now, Reconcile and Solid has a merge option. This would basically be merge always true because you couldn't do a referential check. Basically, merge would be set. Reconcile would only work in merge mode with a key. And if you wanted a non-merge mode, you'd have to you'd do a separate kind of diff thing like I talked about. There is this diff thing is attractive. Don't get me wrong. Perfect examples, you're on the server, produce the diff, send it over the wire, and have the projection apply the diff. So you can do the diff across the wire. And like, in a sense, this is like when we talk about local first and we talk about, WebSockets and stuff. This kind of approach with create projection is what makes create projection so powerful conceptually, right? It's don't get me wrong, at the edge of the graph, it's no different than writing an effect into a store. So maybe, but you kind of, this is what makes stores so powerful, right? The ability to work with diffs. Store, if you have store type technology and you don't have methods like reconcile or this kind of diffing stuff, you're not even tapping into 10% of the power here. I mean, it's the reason why, this was really critical actually for me deciding Solid was viable. Was that I managed to show the diff performance was as good as the fastest VDOM libraries, because it wouldn't be enough like if we just did these reactive updates and just let these other cases just fall to the side. Everyone deals with fresh data from the server at some point. You can't just re-render everything in that case. It's important to have these kind of tools. So, dbmon, which I think I showcased last week, the classic demo, there's actually a really good benchmark from the guy who created the EV framework. What was it? uibench. Local void. Yeah, this one. I'm definitely going to be pulling this one out again recently. Right. What's really cool about this one is you can actually build the implementation locally. This might be something we do in the future on stream, but yeah, Solid's already in here, but essentially it has a whole bunch of tests. It tests tables, it tests tree shapes, and it basically tests all the difficult VDOM stuff. This is the most diff heavy benchmark that there is. This is probably this should just be called the virtual DOM benchmark. And it's a really good way to understand the cost of different kind of diffing algorithms and stuff. Let me see here. Enable full render measurements, disable, no, I'll keep that on. I'll just do a quick run so you can see what it looks like. See, but you can also put a custom URL. This way he didn't have to worry about it. And then I just click this. Oh, that's why. I have a pop-up blocker. I just turn it off for this site. No, that is not how I do it. You can tell that I like never use this thing. Intentionally, at least. That's so annoying. Can I open this link in a new tab? Probably not, because it needs to communicate back to the new window. Okay, I will figure this out on at a different point. Oh, there we go. Disable. Done. Refresh the page. See, it does a whole bunch of like different shapes of tests. Reports the data. And then when you go back to the main page, it actually has the results for all of these. Generally, when I test Solid, I do enable, disable. I actually switch the defaults because these are very good if you want to test the pure algorithm. This is like what it's like when you render with the actual DOM, and usually you'll have referential text. But anyways, this is a great benchmark and probably the one that I'll be referring to as I continue to kind of like go through this stuff. But what I was trying to get at is consider merging scares me in general when things can live in multiple locations, when they might not all be array siblings that can manage by key. This is more primary than diffing. Consider the difference between this. Okay, pretend we're cloning now when we set something to a store. So we got a list from, I don't know, maybe the server, some kind of list. Consider the difference between setting the list inside our store and then taking the first index and setting it versus setting the list inside our store and then grabbing the first index from the list from the store and setting it as selected. A simple implementation of these would have different results. Since everything is cloned entering the store, the first example makes 2 copies of the item at 0, one in the list and one that was selected, right? Because it, like, if you're cloning, it'll clone the whole list and then it'll also clone this. Whereas the second version, we could know that it was the same item because it's referencing the item from the store when we're reading, and we don't need to clone it again. This stable proxy identity is important for equality in things like moving items to list. You don't want to create a new item. Everything is wasteful, and you don't want to merge what is there if it wasn't conceptually the same item as it would be non-keyed that way. Yeah. So what I'm getting at is the fact that these could be different is weird. You would need, if you're cloning, you'd actually like need to make sure that you need the source reference to the item to link back to the clone somehow, so that if you ever tried setting it again in a different location, it would know that you've already cloned and proxied it, right? It's no longer the same reference. Like usually if we weren't cloning, we'd have the proxy. So if you tried to set this up, we'd be like, oh no, we already have a proxy for that one. You know what I mean? But this with cloning, there's like this degree of separation that makes things like way trickier. We have a global proxy map, so we can do that. But if we want the first example to work the same, we need some extra smart when managing cloning. The only way we know that these are the same objects are the source references, but would we keep that around indefinitely? That's one option. Have immutable internals that could always compare against, but arguably we'd only need to keep this information for the lifetime of the set operation. This issue also carries into diffing considerations, because if we reconcile this with a different current product, say product 3, we don't want to transform the existing product 0 into 3, as it would update it in the list as well, assuming we were able to preserve this linking. Key would have to protect us again. But the harder problem now is how to get the shared reference of product 3 in the list. Otherwise, they'd now be unlinked unless keys were globally unique. That they won't help us much. Yeah, I mean, you might not understand exactly what I'm saying here, but there's an interesting problem when you start trying to compare, like do a reconcile, like a diff operation, and decide that the object is the object, that it should have the same equivalent thing when you're cloning. And if that reference happens somewhere else, like basically we have to keep around multiple copies of the object that could link to the proxy. it's a bit of a mess. So things are infinitely easier if there's no shared references, right? If you say that you can only put an object in the store in one location, but I don't think that is a decision that one can make. The exploration above was incomplete, but it led me to conclude a couple things. Immutable diffing can shortcut on matching references, whereas reconciling will never match references, so it ends up deep diffing always. However, this would always be true of data from the server. Shared references establish identity internally. The input of the diff method shared references are the intended linkage in the final result. Key lets us link between input and store, but only as a tool to preserve the shared references. While shared internal references from the server seem unlikely, it is only assumption we can make. Laravel and server functions can handle this because they dedupe, and deduping could be done in user space if desired. What I'm saying is it's possible, thanks to like deduping serialization, to actually, like, if you passed some object that was in two different locations from the server, for it to be the same object. But like basically, sorry, I don't even know if I'm being clear here. You can start seeing the complexity just layer on here when you have to worry about the difference between different keyed inputs that are not referentially equal to shared references within inside the structure itself, and whether the structure that's serving as an input also has shared references. For any of this to work, we need the source input to be linked to the store. Whether that is temporary for the length of the set or for all time is an interesting question. When we didn't clone, store equals previous, but we can't make that assumption anymore. I'm not yet clear the overlap of the different patch operations. We won't realize that even the previous value is insufficient, but I'm not actually not worried about this anymore. I'll continue. So yeah, I started thinking more along these lines, and I was like, can cloning, like, how would we even implement this before we even get to reconcile, like make cloning work? So the first thing I think we need is a weak map. Look, basically we need an additional weak map that would happen like whenever you're called set, or I guess it could even be a map for the length of the set, so that when any object got set in, we could link it back to the cloned object or the proxy. So if we ever hit it again, it would just keep the reference internally. But the interesting thing is, like, we might hit, if we're using key-based operations, we actually have multiple different objects with the same key that are supposed to be the same object but not be referentially the same. So this list might have multiple import sources pointing to the same output. But technically this would work, I think. So, but there is this like interesting awkwardness, because obviously, like, I've got an example here where we pretend if the user created an object, set it, mutated that object, and set it again. The problem here is, if we're keeping this map of references to some cloned object and they mutate their data, we'll see it still as the same object. So this if someone like did this, essentially, even though they mutated it, it'd still map back to the version that we created that was this. So you'd actually end up with a list with ID1 John at both indexes. Because if we used a map lookup to prevent the duplication, it wouldn't be aware of the mutation of the outside object. Again, you probably shouldn't do this. And obviously, if you can kind of see this as dumb here, but what if someone did this? They like had a couple separate set store calls, and they didn't realize that they were just mutating it and setting it again. Again, like, this is not a good pattern. But what I'm getting at is, the whole reason we're trying to do this cloning thing so that people can feel they own their own objects. But this is just the problem in reverse. Instead of mutating their objects on them, we're ignoring their mutations. right? The solution to actually solve the problem just reverses the problem. We could argue that we could keep this for the length of the lookup of the individual set. We use a similar trick for making stores on track. This would at least fix the second case, but is that too specific? Is it weird that this is broken, but this would work because they're separate sets? I don't know. I hope you guys get the problem. Like, if you have an object and you're setting it to a store and you have to clone it because you can't keep the reference, you don't want to like mutate their object, and you do it, okay, well, I'll keep this reference and I'll link it to the clone. So the next time they try and set it, I will just pull out my clone instead. If they mutate the object, then you're going to pull out the clone of the first object as it originally was, not the mutated version. So like they won't get what they expect. I hope that's clear. Basically, what I realized as I worked through this is the only real place for this to work is if we hijacked unwrap, because unwrap has a set for deduping. If we made that a map, it'd be possible to inject during these operations special deduping logic so that unwrap would be able to take the data as it came in and ensure that we deduped. But again, there's going to be special rules here based on like length of the set, length of the reconcile operation. You would only lose the reference if the state was local to the component, right? No, like what I'm trying to say is like, I'm trying to think of how to. I think the problem is I think that our challenge here is the problem statement isn't clear enough. If people believe they own the data line, won't they be surprised if mutating their own object triggers some magic? Well, it's not about triggering magic. It's more like it doesn't do anything. It's like the opposite problem. See, okay, okay. Let's try something. Let's go. Let's go A equals ID 1 name equals J, and const B equals ID 2 name equals H. Okay, so we're gonna go const store set store equals create store AB. Beautiful. Okay. Import create store from SolidJS store. Okay. Okay. Talk about this a little bit. Okay. So let me think of how to do this. Set store. I have to do a little setup to make this work, but if I remember correctly, it's 0. If I set 1 to undefined, or actually, maybe we'll start it like, trying to think of, there's a pattern of changes that we can do to the store that will confuse the hell out of people. But I think this will actually work. If we set 0 to A, I think this will work. One. Okay, so let's switch them. Let's go set 0 to B, set to A. Console.log A Okay, so this one isn't a problem case. There's a scenario in which this swap is fine because we're just switching the same references around. There's a case where if you update it, they end up getting merged. We can't see the console logs. They're in the corner down here. They're kind of small, but they're there. Yeah, I don't think this will actually. I'm trying to think of the scenario of the show where the mutation happens, but essentially, it's like I can make a mutation happen right now, but this is kind of the wrong way to make it happen. Because objects merge, so like this is not a valid case. See, if you look at this, they're both H. But this isn't what I was trying to actually show. There is an actual legitimate case where essentially through operations, when you I think it's probably I probably need to use Reconcile to actually show this happen. And so sorry, I can't think of the example offhand. What I was trying to get at here is if our idea is to clone on set, essentially, like if when we set this into our store here, if we clone this, we want to keep a reference to any object in case we set it again so we know that it's the same object. But if someone mutates it, we end up with the original clone. Let me try that one. Let me see here. So we start with store with data. Reconcile active data. Merge true. And then interesting. And what if I'm gonna guess they're both B, right? Yeah, I mean, yeah, this isn't bad example. The reason this is happening partially is because they're not keyed, but yes, this you I don't think anyone expects that. Yeah, this is actually a good example. Thanks. Because what's happened here is that because the store takes ownership of data A when we create it, when we switch active data A to active data B, it actually changes this into data B, and then it adds data B. So now it's not just the fact that this is the same in here. It's the fact that if we console log data A, it shows B. Thank you. This is a good example. See, we can add a key property, for example, here. Key name. And this actually keeps it separate here. But I think the challenge here is that like there's definitely cases where expectations based on whether they're shared references or not can open up a weird can of worms. Oh, sorry. Yeah, I need to. Yeah, sorry. Right. This keying actually separated it, but like you can see that without the keys, like this morphs this, which is different than this, right? So like key kept them separate because they realized they were different objects, but without the key, it merged the one into the other one, right? You'll see that A is B at the end. Okay. So generally speaking, keys with reconcile is important, but it's more than just that, which is what I've been trying to kind of get at with all this, is like generic fixes to this are inconsistent. So maybe I just have more work to do. Admittedly, cloning seems like a good idea, but it reverses the problem. You want to clone because you don't want to steal from the mutable sources, but at a certain basis, I think we have to recognize that we have to own the data being put into the store. It's definitely a tricky problem. I'm gonna continue on this path because I can at least see how we could try and implement it, but you can start to see like it's not hard to picture how if like let me like pretend that we are like, where's the other one? Where was it? This one. Pretend like there isn't even reconcile. Pretend you're doing like a diff and you take some objects from an immutable like Redux store, and the operation is like apply this patch to the diff. Like sorry, was it immer here? Was there an example? Like one of these like operations replace, pretend the value is like an object, and then we hijack that object in the store and we start changing it, and then the reference inside immer is no longer the like the like the right reference. Like if you don't clone, you do risk regardless, taking ownership of that. And if you do clone, it seems like there's a lot of awkward trade-offs that need to be worked through. Yeah, well, the store diffing is an important part of the stores because you can't always know the granular changes that need to happen, especially if you get stuff. So like going to mutable reactivity has the ability to communicate downstream changes without diffs, but there is presumably at some point, unless you start on the client where you have all the details or something, there's probably somewhere that needs to do a diff. Most often that's the point at which you do like the async fetching that we need good solutions around. Okay. So what did I say here? I'm going to benchmark this. I'm going to try some stuff. I need a little bit more exploration here. It seems if we could do cloning in an effective, consistent way that was performant, it would be more predictable for people, right? But the reason I showed this example is because some of the things, like if people mutate data themselves, we're kind of out of luck anyway, right? Like this was an interesting realization to me, maybe less to other people, but it's like all the mechanisms to try and protect ourselves seem to also just reverse the problem. Anyway, last section here I'm going to talk about is what if we did want to do an immutable diff, if we didn't want to do immer. There's some interesting stuff here. Could do hashing. That's interesting. Hmm. Actually, probably. Oh, that's interesting. Yeah, because we don't actually care. Yes, I think so, actually. Because you're right, the reference isn't what matters. We just care about the actual data. I do think so. I think this is getting that realm. Isn't it better handled without changing curve behavior? Basically makes it you understand how object reference works. Yeah, the only challenge is there's a create immutable inside solid primitives that exists to do the cloning. I made this for the guys for XState at some point, and then like it ended up in solid primitives, and um, I think what I remember when I was looking at it was internally we can do something that's very hard to do in user land in terms of optimizing this kind of approach, but it's possible that I've just overcomplicated things and I need to step back a bit and take a refresh on that. It just, I ended up going down this path because, it's like, can we fix stores? If stores are such an important part of the future, can we fix them? And the answer might be no. Like this might be part of its nature. This might be part of the realization here. Um, but yeah, interesting thing. I don't know. Have you all seen this before? I actually hadn't. I didn't realize there's like a generic established patch format. This is what Immer uses. It's actually basically a standard. The difference is this uses a string path instead of an array path. Immer used an array. I would use an array too. It makes way more sense. But it basically defines a generic diff format, and apparently it's actually like some sort of standard. So it's definitely interesting. Um, I actually this is probably more interesting to people who want to get into more details here, but I had actually started playing with the idea like I was like maybe my only grief with this approach was that it seemed like it produces like a flat set of changes, and I was like, wouldn't it be interesting if we could do like a hierarchical diff so that like we could apply the operations without like stepping in and out all the time, and like without going all the way up a path and applying it, all the way up a path and applying it? Wouldn't it be cooler if we could like apply all the changes as we went? So like I started playing around with some like formats where like I made the path the thing, but yeah, I don't know if this will be interesting to everyone, but essentially what I realized like this one's actually awkward because you can't do lookups very easily because it's just based on array index. Because as you add the patch you like don't know. Then I started playing around with like what if you use the path as objects, which wasn't bad. um this is kind of the problem is you start losing order of operations, but maybe because they're localized it doesn't actually matter. So kind of start going through like ideas. This is for immutable diffs, to be fair. This is a different problem. List unshift, push this, set a name, unshift. So I always love using unshift or shift because affecting the beginning of the array seems to mess with everything. So this whole like, what if you like push something to the front of the array, changed it, pushed something else to the front of the array and changed it. But if you had multi operations at the same key as an array, then you keep order. Then I was like, okay, well, what if you change the order So push these on and then do that, because now they get grouped. So technically these would get applied out of order. Like you do the operation, then change the name, operation, then change the name. But this is actually fine too. Then I was like, what if we splice something in the middle? But again, it actually all works. So I think the funny thing I concluded at the end was that comparing this diff that's hierarchical with this diff didn't actually save us any work, because the root path isn't nested. This only saves work if there's shared sections of the path. It is actually technically smaller output, but I think I'm probably over engineering stuff. Anyways, just another random thought. It's a good question. I don't know. I should go ask over there. This section, or this, what we're talking about here, mostly I just want to bring attention to the fact that there are implications of trying to manage diffs on mutable data, essentially, because of shared references. And it might make sense to pull the diff outside and apply it inside, essentially. It's interesting regardless. I don't think there's a world where we don't need some mechanism for diffs, but it's definitely looking at the complexity that kind of comes out of this. I'm almost at the point now where I'm thinking that maybe, and I'm going to have to benchmark this, but maybe Reconcile is a mistake. Maybe we should always be doing immutable diffs and then just have the patch function clone the object. So essentially stores themselves never actually clone. They assume ownership. But if the patch ever sets an object, if it does the clone coming in on the set, and it does the immutable diff, like maybe that's always just the better option. It's a little bit more to write per se, because you'd basically have a projection with a create memo. But like, I don't know. It seems like I'm going way too deep on solutions that are kind of crazy. We might need our own diff so that we can do like ID based, like key based diffing. Most tools like expect React to do it, so they don't do it. But it's just like it is surprisingly awkward. Well, yeah, the thing is, I think Mitchell Westrate said this once, is that he was saying that this is outside of the scope of MobX, generally speaking. Like he was like, that's why MobX state tree exists, right? Or Immer exists, or that. So like I think this piece could be seen, like there's lots of options that don't need to necessarily be part of the core store implementation. Like a conclusion might be just that like maybe we do provide a diff, but the expectation is that stores themselves don't change, but the way we apply diffs change. That might be the best of all worlds. So yeah, at least this conversation let me think out my thoughts a little better. Create Mutable is going to be shipped off to solid primitives or legacy or something in the near future, because the plan is that the store API is going to accept the produce syntax or the mutable syntax as the primary one. It's still going to have a setter, but it doesn't make sense to have two different types of stores when they basically do the same thing. Right? We want to keep all the characteristics that are read-write segregation, but we want to make it easier to do updates. I mean, don't get me wrong, I love the path syntax. I came up with it for a reason. It's succinct, it's declarative, it's beautiful, but it's like Reconcile is. It's like it's something built, it's a helper. It should be a helper built on top of a more fundamental basis. And through this exploration, I've realized, like that the stores are in their essence mutable, right? So it is that good that they are. Some interesting things that you all might find interesting about the new implementation of solid stores that I've been playing around with, to create store for the 2.0 stuff, is um, how to actually get the right to do it. Because like what I'm doing is I'm actually setting a global set for writing. So when you create a store, or so when you call the set function, it adds the store to this global writing thing set, and then it clears it when it's done, the synchronous store set, which is, and then when you're inside the proxy setting the thing, it asks if the set has the target, and if not, it doesn't write to it. So essentially, in this way, we actually use the same proxy for the read and the write, but you can only write to the proxy during the execution of the set store call. It's cool because it keeps references this way. I also use this trick. If you look on the get side, we use this trick to actually make them non-tracked. This is another classic problem with stores. Like if you write, I mean, I have an example in here. Like if you write something like this, doesn't this mean that whatever scope here is going to actually be tracking draft.list.0? Like you're trying to write to something, but you end up tracking yourself by accident. So basically we're using this mechanism to basically guard against both writing and against tracking yourself with inside the set function. So there's like a bunch of weird edge cases around. Yeah, like this gives us a lot more control and guarantees. Like before, we were like I was setting like a global like MobX, they have like a strict mode, right? Where it's like you can only write when you're inside an action. This is keying it even more specifically to the specific store, so to speak. Anyway, I have not looked at CRDTs in detail, to be fair. It might be interesting to look at the diff format. Then again, one thing that I did realize through this operation, which I didn't talk about at the end here, going through this thing, is I start worrying about, like, I noticed that this worked, but then I noticed in the spec they have like move and copy and these other operations. But then I realized I was like, how do you get a move or copy operation out of like a mutation set of mutations? You don't really. And then I looked at Immer's source code and they only do add, remove, or replace, which means that I think that from our perspective, there's only a small subset of actually diff operations that we actually need. We in fact need to only implement these three. So I'm not as worried about the diff format. I know I wrote a whole thing here about how to hierarchically basically optimize the diff format for applying patches rather than for creation. It was essentially what I was working on. I don't know if people realize that the path syntax in Solid started because I was trying to actually come up with like a diff format. I was trying to make my own version of Redux based on merging mutable diffs, and the path syntax was originally my syntax for figuring out how to apply changes. Set store used to take arrays of arrays, so that you could like have an array of paths, and then I decided at a certain point just not to do that. It simplified things, so then we can make arrays top level, for example, in stores. And we didn't, because instead of passing an array, you pass in the list of arguments. So like we got rid of, and it was awkward having a double array wrapper syntax. It just, array of an array, etc. But definitely my gut feeling here is that the diff format or patch format is not the most important part of the problem here. Actually, I think this is actually simplifies drastically. I think that writing a diff or even using existing tools like Immer, if applicable, kind of alleviates some of the tension here. Right. how should I put this? These are a diff and patch algorithm from reactivity perspective. The only thing is, like, I guess I'm often thinking a lot of this stuff is coming from outside of the system. But yeah, I mean, maybe I should take a look. You guys seem to think it's relevant, so. Like, I'm looking at something that basically has 3 operations. So, like the patch part of Immer is a plugin, but it's also probably a fairly straightforward routine. Anyway. Okay, let's see, 420. Okay, I got a couple more updates. So unless you guys want to talk more about stores, I got a couple async updates here before we get into this week in JavaScript. This should be quicker. If you remember a few months back, I was all talking about run once reactivity and, you know, ways to fix suspense and all this stuff. Having a bit more time, I realized that my crazy solutions all didn't work. I'll explain pretty why, but it's actually there's 2 types of problems that you have when dealing with async with its signals graph. You have what I call lazy async causes waterfalls, right? Which is like, if you have a diamond, if A is a signal, and then B and C are both async, and then D is the combination of those, if B and C are async and lazy, and only read in the effect, what would happen is you'd read the first one, and I should say lazy async causes waterfalls when you're throwing. I'm assuming that non-nullable async is your baseline starting here. But essentially, if you get here, you throw, and then you have to wait for this to resolve to run this and throw. So if you're being lazy here, you actually don't fetch this until after you fetch the other one. It's an immediate waterfall, right? So if B and C are async and lazy and only read in the effect, what would happen is when you read user and start fetching, then throw, user details wouldn't read and fetch until after user resolve. You could guard to prevent this problem, right? You could be like, if it's pending and is not basically if they're both not pending, grab it. But the reason this would work is because the pending would catch the throw, essentially. And that way, like, it would basically fetch here and fetch here. Like, so this would go, throw, this would catch it, but it would fetch. This would run, throw. Actually, does this even work? I'm probably wrong. Yeah, this and will short circuit it. This code doesn't even work. This code doesn't even work. You literally have to say is not pending. Like, you basically have to actually. I should edit this. You see the problem, right? This short circuits the way I wrote it. You essentially have to actually do this. I was trying to be all compact, but the reality is you actually have to. If not is user pending. More like this, user pending. Details pending. Turn not. I'm sure I could have done this with an or in a shorter way too. Anyways, my point is it's this is not nice, right? You could use pending the trigger the fetch, essentially, if it was lazy, and then guard against it. Details. But this is not lovely. In this case, each throw would get caught by its pending and each fetch would happen, but it doesn't get us much. Non-throwing approaches async don't necessarily have this issue, but might require guards anyways if they want to avoid undefined, right? Because you'd have to check if they're there. Like it's the same pattern. Even if you initially fire off the request the first time, updates will have the same problem unless you tearing, right? Unless you opt into tearing, keeping old state while new async is in flight or schedules fetching, right? So what I'm trying to say is like this guard is probably wrong too. Actually, yeah, because this fails and doesn't call this one. Yeah, God, I gave it too much of a benefit of the doubt. It's more like this. This is pretending like it's like solid today, where it's just undefined. So you actually have to do this. U N D U D. All right. Fixed. Okay. No, I'm missing whatever. Okay. My whole point is that this is not very convenient with lazy. So the only way to get around this is if you fire the request the first time. Even if you initially fire off the request the first time, the updates will have the same problem unless you opt into tearing, keeping the old state while it's syncing or schedule the fetching. Yeah, so what I'm saying here is even if you aren't lazy initially, like you just, when you declare this, it runs right away. The next time you do an update, because these are both based on A, right? So you update signal A and the effect runs. Where's the original version? Yeah, and the effect runs. This is using the new split effect syntax. But the next time the effect ran, you'd hit the same problem because now you'd be throwing or now you'd be undefined, right? So, like, this doesn't go away unless perhaps maybe you show the previous value, right? Like, but async tearing is wasteful. So when I was working on this run once thing, because that was my idea, I was like, we run it immediately, right? Like, fetch immediately. So the first time we get, we don't have to worry about it fetching. And then the second time, we just give the old value of user and the old value of user details. And that won't cause us to update. But on the positive, both will fetch again because they're lazy. They'll both fetch again. But because they won't be blocked, because they won't throw, they'll just get the old value. But there's a problem with the old value. This shape. If you have a signal that feeds into an async that depends on async, but this signal also is read by this one. So I have an example of where you use a signal to get a user and also get a best friend based on their user ID and their friend's user ID. Like you want to get the friendship record, let's say, the connection between these two people. So you can use the base user ID and you can use the best friend ID off the user. So B and C are async, okay? This is an unavoidable waterfall, right? You can't get the best friendship unless you get the best friend ID off the user. You can't, this is a waterfall. You can't avoid it. However, run once not throwing is detrimental here. When A is updated and it notifies B, and C, they both get queued to run. B runs fetching the new user. Then C runs. It sees the existing user here, the old user, with the new user ID. And it fetches the friendship information between the new user ID and the previous user's best friend. Then this completes, updating the user record, which sees a new different best friend, and then it fetches again. So instead of it being a waterfall, just a waterfall, if we use fetch once kind of thing where we like let it resolve and not throw, we actually end up fetching here twice, even though technically we should fetch here and then fetch here. Tearing we accepted for UI, but for data fetching, it's terrible. It's possible to guard this. Usually we null check, but is pending could be used similarly to remove intermediate fetch, right? If not is pending, you know, this return fetch, you know, this. But the funny thing I realized, the solid today is actually like this because we don't set undefined with a resource. We keep the old value, right? Technically it suspends, but if you ever chained async, which we don't actually do because, you know, it all depends, people don't do it much. We actually do this. You're probably already doing guards around this. If we nulled out values while fetching, we wouldn't have this problem, but we'd also have some pretty blotchy UI unless we said suspense was necessary. Even transactions and transitions would be subject to this double fetching because when working on the alternative reality, async still is an instance. So there's no real guard except the one that we enforce or the one the developer needs to put in themselves. Okay? So basically what I'm saying is we haven't hit this problem very much, but in a sense, Solid's approach is a little bit like forces you to manually guard here when you chain async, which is kind of awkward. So basically what I'm saying, if you follow this conclusion that like if you're throwing and doing this stuff, that you can't be lazy, essentially, because you can't tear. There's really only one option. Suspense is necessary. Making it optional doesn't work if you don't want to tear. Tearing can be unpredictable. It isn't just part of UI. It could be data fetching. It could be, you know, in the UI, it could be missing classes or rendered elements or other oddities, but not everyone wants to use suspense, but when they essentially recreate it or transactions in their attempts to not use it, you put placeholders in your UI or you leave the current data in place and place loading guards around downstream calculations. The biggest opposition to suspense is that it's jarring when things under it cause it to fall back. The answer is usually to go more granular, but if you want to default values, it is a bit awkward because you can do that at a single point high up without upheaving everything below, whereas suspense being granular would need to push down pretty far. You can opt out of suspense with guards, like it's pending, or even look at a way to resolve the last resolved value, like latest, which I was talking about. Or I keep on going back and forth whether I want to call this. But essentially, it makes it difficult. It's perfectly fine if people want to guard against specific behavior, but it's difficult to have the default behavior cause data to be fetched multiple times or cause weird tearing to happen, essentially, right? It's very difficult to say, like, it's going to do a bunch of broken stuff unless you do something. Let's talk about latest for a minute. Although a good point here is latest can only be resolved shallowly. We can't stop a dependency from throwing in the first place, but we can instrument the read, and we can't guarantee that it doesn't throw. Yeah, okay, yeah, I have an example here. User, fetch from some ID, first name, create memo, user first name, first letter, latest, first name 0 to uppercase. Initially, there's not a value, so latest at minimum needs to be a try catch, right? Because if you tried to read first name from here, it's not going to be defined, right? Like even obviously it can throw if it's never been evaluated before. But even if like we told it not to throw, it's going to be undefined. There's no possible way this has a value, right? So like while we could say that under latest this could just return undefined, it's going to throw the second you try and get 0 out of undefined. So a latest helper actually needs to catch and squash basically all errors that happen under it and either return the value or undefined. That's basically the operation. It's like try and get the sync value or return undefined. It's not actually latest. It's not actually like a history. It has to be like attempt to resolve this syncly, which is why I kind of want to call it resolveSync, except resolveSync also doesn't make a ton of sense. Let's assume it resolved to John the first time, but now we go fetch the user again and something else causes us to look up the first letter. When it goes to read the latest, again, even though first name should throw, it is in latest mode and will return the value John, which will get us the J safely. One thing that worth noting is if the memo or async has a default value, then the latest would be able to always resolve out of value. Part of me wonders for that reason if the helper itself should take a default value. Then again, you could always just OR it. What I'm saying here is if create memo here has a default value, then when it goes to read, it's in this like latest mode. It doesn't need to actually throw or be undefined. It can actually be this default value and actually resolve. It's kind of interesting that you can set defaults through this mechanism. Latest might not be the right name because in reality it uses the latest value. Something in the future could cause it to fail. We don't get the latest value, we get undefined. So it's more like a try catch with a special mode switch that tries to resolve syncly. Like resolveSync maybe. It doesn't force us to resolve synchronously though. More like a try to resolve synchronously. Maybe latest just reads better. So basically run once doesn't work. There's no way to avoid scheduling. We need to always throw or force undefined. So we need suspense. We can have better dev tooling around it, but that is what it is. Guards can be helpful, like it's pending or latest, if we don't want to suspend in places. But fundamentally, if you don't want the fallback to happen for data that you did initially suspend on, we don't have much recourse except to perform transactions, or the developer has to use the old latest user or user trick. That just isn't the default the system can take when propagating change through the graph, right? The whole reason we were looking at this run once thing was we were thinking, couldn't we make all user reads be latest or user, essentially? That was the revelation like in the summertime a few months back. And I think the answer to that question is no. It's just not a safe default. If you know that's what you want, go for it. But we can't actually make that the default behavior. The current behavior, minus the couple like bugs and the changes due to throwing, is actually closest to the right behavior, I think. Do push-pull lazy async memos bring benefit? I saw in the previous slides their performance benefits, but they also make things more complicated. Do they really matter for the... Well, here's the funniest thing is I talk about this in my article series. At this point, because in order for this to work, async has to be scheduled. The only thing that is lazy is the memos now. Everything else is scheduled. Async scheduled, effects are scheduled. We've actually reduced the surface area of Solid's reactivity significantly with, projections and like this kind of thinking. Obviously, there's a lot of utilities, but, with the createWritable signal merge and stuff, we're actually getting down to like basically having 5 reactive primitives. And not 5 with a bunch of dot blanks under the hood, like signal.link or whatever. I mean, literally 5 primitives. But yeah, I don't know. It's funny. Solid is the only non-lazy system. All the other ones are lazy. And all I've managed to show here is that most of the time lazy doesn't actually make sense. Most of the time, like for most things. I think memo, like computeds, are like the one place where they make sense, but almost everything else needs to be scheduled. So I don't know. Current? Yeah, it's really interesting. It's not latest. It's not even current. It's like, I guess it's current. Yeah, it is current, isn't it? Because it's not the last resolve value. It's like try to get what it is right at this moment. Yeah, but like when I benchmark the new version, that's like, well, here's the thing, like when you do a benchmark, like a rendering benchmark, how many memos do you create that aren't being used? The fact that the memo's lazy is irrelevant at that point, because like in Solid, render effects and memos run immediately on creation. And in fact, I think async, I'm still, even with the not late with the scheduling, I'm still going to run it immediately. So if you are going to eagerly run the stuff, even though you have what eager like scheduling, like you schedule everything, so it's like eager resolution, not just pull. Like we're never going to find it's very rare to find benchmarks that are like tests that actually show the impact of having lazy memos, unless the benchmark shows situations where not everything needs to be calculated, like that one like preact signals test. It's like something that you basically never hit in any focused like application scenario. It only happens when you're like in real life. It happens, there's sometimes parts of the graph that are disconnected, and it happens like in these like very fictional kind of situations where you're like almost testing for it. But like if someone goes and makes a benchmark, they're not going to like make additional memos that aren't going to be used. So it is kind of hard from a benchmark perspective. I have hit value in this kind of lazy calculation and pull approach when like interacting with other libraries like React, because they're pull based. So like deferring the work can make a lot of sense until like React wants to see it. I love lazy memo kids. Mike Pearson had a whole article how eager signals remove the benefit of cold observables. It's true. That's why our from operator wasn't that interesting. But then on the other hand, like, yeah, that's probably where your benefit is, putting lazy memos at the end of event streams, because you need like a potential sync to be there. You need to make the thing. Then again, like create async. I mean, this is more fun for you. Again, create async essentially is you should be able to just pass an observable. If you go create async, return observable, because it accepts async iterators, but then this one is not lazy, so I don't know. It's funny though, because create async is probably going to, like, I don't need the from operator anymore now that I have create async. Couldn't you like just defer hooking the stream up like until you want to listen to it? I don't know. But yes, generally speaking, like if you look at like my scheduling logic commits over time on the solid signals repo, it's just like more and more and more stuff is just going back into the queue again. Anyway, done. Talked about those. Okay, let's get a little bit of this week in JavaScript in before we're done. Give me 2 seconds to get that together. Observables aren't async iterators anymore. I mean, they never exactly were, but wasn't there an interrupt for them? Like, I mean, RX. Now I want to look this up. RxJS async. I thought like people just put the symbol on it. I see. It's still open. Oh, I see. So basically, although I see something merged here. Sorry, let me go back to sharing my screen. Give me 2 seconds. Oh, okay. So this was merged in 2023 and then they like went against it? although it looks, he mentions that library in the PR, core team approved. It looks like this got merged, but like there is an RX408, but he's also saying that this got merged. I guess we'll have to try it sometime to find out. Okay, give me a sec. Oh, actually, I had one other thing I wanted to show. I mean, it's not a big deal. The reason I pulled this up was that I actually proved that in the new implementation for Solid, Reactivity actually implemented both that triangle and that diamond, and they both work. They were like test cases from what I was showing, like where B and then C, and then front is like the front half of the effect. Then you see C fetch later. Yeah, and you can see the waterfall happening properly without double fetching. Anyways, not that important. If you care about seeing this example, you can uncomment either or. But yeah, this is the triangle, and then if you comment out the triangle, you can also see the diamond. Sorry. Which is, you see them both fetch at the same time, and then as they update every interval, fetch at the same time, fetch, effect, fetch, effect. Anyways, just stuff. Okay, let's go back. Okay. God, there's so many notifications right now. Did I kick over a hornet's nest before I went on stream? Whatever. Okay, 2 seconds. I'm just setting up my Twitter tabs. Guess people want blue sky content at some point too, but that's not completely where I'm at yet. Okay. Last time we streamed was September. Yeah, okay. Good, and good. It was September 22nd, I think. Okay, let's go through this stuff. And solid is here. Okay. Sorry, October 22nd, not September. All right. All right. Cool. People still alive, still awake? I know this has been long, really deep. All right. Okay, so I'm going to talk about this week in JavaScript. I don't know if I'm as connected these days because, as I mentioned, it seems like there's a mass exodus to Blue Sky, which was kind of nice. It was quiet, got work done, as you can tell from all the content in the stream. So maybe it's good that everyone went away. First, a little bit of solid bookkeeping. SolidHack is still very much in progress. Open the actual link for this. More challenges. We've been doing ones every week. Been great payouts so far. A lot of really, really cool contributions. There is only 5 more days left. So just word out to all you all. It is coming to a close, but it's been amazing. Right, yeah. Some of this is one of my favorite things is we've been doing rewards for guides. So like much needed like how-tos for Solid Start have been coming out. Like it's funny, I build all these things, and we put them together and write some like bare minimum docs just to kind of like keep on moving forward. But then it's like there's so much hidden potential when you put the pieces together that really needs to be highlighted. Every day someone's like, oh, how do you do this? And it's like, oh, I haven't thought about it. Oh yeah, you just do this. And then you like put it together and you're like, oh wow, this like you could write an article about that. I'm not going to. I've got other stuff I'm working on clearly, but like there's a lot of power here that's barely being tapped. So I think the especially the guides bounties have been really, really good. Anyway, yeah, let me see here. Yeah, no, Attila's been doing some great streams recently on some of these topics too. What you're seeing here, so just little solid news type stuff. What do we got here? I've been having some trouble doing the retweets on because I don't know how many of these projects are actually the voting's going to start soon, and people have been building some really cool stuff, and I'm like, is this SolidHack or not? Like this library from Dev using useSocket as a way of doing WebSocket, server signal type stuff. Really, really cool demos. Yeah, Cobalt's getting more and more UI components. Yeah, here's the data UI guide challenge. I think we retweeted that somewhere in here. Yeah, this has been my biggest challenge because I don't want to like bias things, but like it's really tricky when there's so many cool demos here. This is Trello using the server signals. Another cool solid piece of news. There's a book. I almost wanted to see if I could get it printed, but this book's been in the works for like 2 or 3 years now. But there's a full like how to use Solid book, which is pretty freaking cool as far as I'm concerned. Yeah, I don't know what to say beyond that because it was shared with me. So I looked through it. It was very detailed, a lot of chapters. I mean, you can see it kind of from the overview here. But like, there's a book. We've accomplished something. This like, it's very, very cool. I'm very happy to see these kind of projects come together. More challenges, Blue Sky account setup, more conference talks. Again, I posted this and then found out there's a SolidHack contribution. This is Solid Desktop written in native script, develop Mac OS with SolidJS. Honestly, this thing looks crazy. It's really cool. I keep on hearing people say, "Oh, before it's like I develop with Solid if there's a meta framework," and then the next thing is like if I could do native or other platforms, and it's like that area is catching up between like native script and Tori at such a rapid pace. I don't know if people know this, but like in terms of Solid's adoption in large companies, some of our biggest adoption is through non-web platforms, right? It's hard to convince people to move off React because it's good enough, right? But there's certain television development especially is a place where Solid's getting a lot of ground because of the low memory footprint. So like other platforms it's an area that React Native has crazy solution that's way ahead of most other solutions in terms of how long and how much effort's put in. we're getting pretty close to a point now where, thanks to native discriminatory, that like this doesn't have to be such an equal ground. You can be like, yeah, I built my application in Solid. I built, Solid Start for the web app, and I built it using Tori for native, and that's a real thing. So I don't, I mean, the scariest thing about what's happening with Solid right now is everyone's running out of excuses. They just got to admit that they just don't care. Which is a fine position to be in, but like the excuses are getting pretty thin at this point. It's like, oh, it's because other people aren't using it. It's like, yeah, but if you use it, maybe then other people use it because they'll see you using it. It's like, it's the like who's gonna jump first kind of scenario. So yeah, it's kind of funny that we're getting to that point. Honestly, that's the best point I could hope for. There's only so much you can do. Isn't Tori a web view? Yeah, it's interesting because this was explained very much in detail on stream, but it's not like capacitor or like ionic. Like it's not like it just runs just straight up like oh, here is a web view and you're doing everything. It's much lower like level integrated. It's not the same as React Bridge, but it's not like, my understanding is not just like the straight up web browser. Okay, is that it? But you have access? Okay. There was a very detailed explanation when I watched in my native script and Tori streams that I did a year ago. We focus more on like because Attila was trying to make me like less afraid of like Rust essentially. So we were looking at those aspects more than the solid aspects. I mean, there's definitely a JavaScript executing layer here. But yeah, there were subtle details, and honestly, it's not an area. Yeah, honestly, sorry, this is just a side. I just saw this, but this actually has been really annoying. All the references to embeds in my articles are gone now. And no way to get them back. Anyway, where was I? Let's go forward. Okay, I'm gonna flip over to my profile here. It was funny. We were updating. It's kind of interesting little side story, but we're updating the solid site for the JS framework benchmark, and it kind of asked a question of like, what do people want to see in benchmarks, right? Fastest versus common. I'm glad that common won by such a huge thing. We actually went with React hooks and Preact classes because I followed the docs in the end. But it's kind of an interesting question, right? Because this is kind of like the current state of performance in the JS framework benchmarks. And if you look at it, Preact hooks and React hooks are almost identical in performance. But I was like looking here and I was like, Preact was way up here before. It's because these were classes and the React was hooks. Over time, classes have gotten more performant. It never used to be that way. So I was like, is this fair? Should we use the class version for both React and Preact? But it turns out that React has basically said that classes are legacy, where Preact actually has both examples in all their docs. So I went with Preact classes here, and then we kept React as hooks. So I think that was the final version here, which looks like this. So yeah. So yeah, no, it is an interesting dilemma though, because Preact also has a signals version, and some people are like, use the signals version, but it's like it's kind of like in the middle. We already talked about that. Okay, yeah, let's talk about early returns. I talked about this a bit earlier, but I missed this article originally, and yeah, component composition is great. When I first learned about Reactive, blah blah blah, virtual DOM paths, blah blah blah, separations of concerns. Okay, so it talks about conditional rendering, and one thing I do really like about this example here is he's basically showing a pattern where you can hoist the logic, the layout out of the logic, right? He's showing that like as he goes, he has to add all the more conditionals. I think part of the problem with this is the problem isn't that there's conditionals. The problem here is that you have mutually exclusive conditions. There's a difference between conditions that are like turn this on and off, and ones that are always mutually exclusive. So like the complexity comes in here was that, oh, they missed the empty state, but it's because basically these are all mutually exclusive. At least these two end up getting tied together. But if you think about it, all of these are actually tied off the same thing. They're all based on the data prop. So fixed it, empty screen. Okay, back to the drawing board, right? Pulling out the layout is smart. It lets us focus on what's here, right? But the idea here is that if we separate these mutually exclusive states into separate things, then the code is much easier to read. Instead of trying to like go, okay, what's this combination? What's this combination? What's this combination? What's this combination? You now can go, when this, do this. When this, do this. When this, do this. So, and the argument is reduced cognitive load. Yeah, right. Clear path for other. Nothing is nested. Like async await, it becomes easier to reason about when reading top down. Async await is like the worst thing in a component, but that's a whole other thing. Even if a statement with a return represents one state the user can see, notice we've moved the data assigning to the last branch because only one where it matters. That's true. Easy to extend. Yeah. Now we can also add more conditions like error handling without fear of them breaking other states. It becomes simple dropping when an if statement. Except, again, this works because all the heavy loading is happening here. If adding error conditions required you to go to here, and go to here, this might arguably be worse, right? I think it depends on the type. Better type inference, right? Because not data means this thing, right? But the complaint is layout duplication. You're re-rendering the layout component every time. Now, as you guys know, in Solid, re-rendering the layout component every time is about the worst thing you could possibly do, right? So like, but also we don't have early returns, so we can't really do this unless you put in a memo, which then it also is about the worst possible thing you could do. But my grievance with this is that it was twofold, because I saw this article and I was like, this is not great. Like, I understand that you want to optimize readability over optimization, but the layout. But the fact is, what's the difference between early returning and just recognizing that this is a, trinary or whatever? It's like three possible returns, right? Like, I think the thing is, at the beginning you treat them all like they're flat, but if you actually make the same, see, when you switch to early returns, you decided that these are three mutually exclusive states. If you make that same assumption about your code anyway, you can like slightly change the code layout. Yeah. See, yeah. So for example, here, don't get me wrong, I'm not a huge fan of going ternary, 1, 2, 3. But actually, let's put this into a place that has syntax highlighting. You can see what I'm talking about. Do I have a syntax error? The reason, oh, did I miss? Yeah, the reason I wanted to, is it this? What's this? Something, okay. Let's try this again. Yeah. When you lay it out like this, not only are you not like duplicating the layout, you are actually still doing like, it's like the early return. You're just doing like this, then this, then this. There's 3 data flow paths. Arguably, this is slightly less clean than the if statement, but it is still bang, 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 right? The funny thing about this, though, is from like the alternative perspective here is, if this is the baseline, is early returns just a different templating language? See, you can't put a hook in between after the first return. You can't like put a hook here, right? All hooks, all data stuff has to be here. Basically, even everything below your last hook technically is the template. So in a sense, a different way to look at this is just an alternative template syntax that's not JSX, but it's still templating, because you still can't actually nest state down here. So everything after this is technically the template, right? Which means that effectively all you're doing is adding an additional way of doing the same thing you could have done in the template. You're using statements instead of expressions, sure. But like, you're doing this for convenience in terms of that. The other problem with early returns, kind of fundamentally, again, it doesn't impact React very much here, is that essentially you're ensuring, like, keep in mind, consider the difference between these 3. When you have a condition, early return, if you change this block or you change just the text, when something changes, this is all that needs to change from like a fine-grained perspective. It's only the condition needs to change. The higher up you hoist this, the more work you have to do. You almost always want to actually push the conditional logic as far down as possible. Obviously not at the cost of, breaking apart mutually exclusive paths necessarily, but from a pure work standpoint, this has no choice but to rerun the whole component. This runs this, and this reruns this. So like, how did I phrase it here? This made me reflect on how far reacting is from RAM. Early returns lend to architectural inefficiency. It pulls decisions upwards where further farther positions are pushed down, the more optimal they can be. It might not impact React, but it doesn't leave a way forward. Yeah. Starting to focus on readability, right? I think you agree the last thing with the higher end with all these inline ternary, it's very hard to compute your head what actually is rendered at a given time, because they're not mutually exclusive, is what I'd argue. For some reason, there's a right route. The advantage of having a compiler, these kind of options can be done automatically, no anything. Even if I take that at face value, I wonder about the philosophically. The compiler has limits, and if we teach people that they don't need to think critically about this, then are we teaching them the wrong things? They lose the ability to understand the implication of their decisions. Readability is only compromised here because of syntax. Ultimately, the early returns are just as restrictive as single return. Hooks can't be declared after the first return. So we are gaining in hoisting and unwinding is mostly introducing a secondary statement syntax to our template. Everything after the last hook is part of the template. To me, it's a wash on scaling cognitive complexity because the nature of the enhancement determines whether it aligns with the split or causes additional duplication that can lead to missed or lead to errors. I often say premature boundaries are the enemy of future optimization, and this seems like a way to add more with very little upside. Yeah, because what I was gonna put in here is he was when he was talking about, like, in the article, like, oh, look how you don't have to null check data anymore. Well, guess what? You don't have to null check data in this example either, right? Because the conditions still exist. Obviously, the reason I say it's a syntax thing is because it's messy, right? The ternaries are messy, right? But if I think Pierre wrote something here. Essentially, there was an example that showed do expressions somewhere down here. Yeah, what was it? Do expressions? No, it wasn't that one. But like even Solid's control flow basically alleviates the readability, or Svelte or Vue's control flow. It alleviates the readability. It's just kind of interesting to me that, like, conceptually, the return single template languages actually have only a single way of doing this kind of control flow, where React offers like a secondary way by allowing early returns, but it also like pushes people to making inefficient decisions. I think people that care about syntax, though, yeah. I never said people were smart. I'm sorry. One of my pet peeves is people over indexing on syntax. Like it's just like this. It's the thing that you can just be like, oh snap, I changed it. Like it's yeah. Switch match. Sorry, switch match is a good example. Yeah. If create variables, the thing is, we can actually create variables nested in control flow. Like if you do like a show, you can actually create signals inside the show component callbacks. But like, yeah, no, yeah, just create better syntax, which is what I'm saying we have, right? And I think templating language have, and you can with JS. Like, I'm just saying, like, it's it bugs me that when the solution pushes you towards less efficient approaches, it bugs me. Like it's like, oh, we should early return. It's like, no, we shouldn't early return. We should like step back and think about what we're doing here. Early return is like, this is what I meant by not leading to a way forward. You know, maybe it doesn't matter in React, but this is always better than this. Like mechanically, like there's no, like this is the absolute truth. There's a great follow up here where where was it? I tend to optimize for humans first, then performance. If necessary, I value readability very highly. If I can't understand your code, then it's difficult to refactor, introduce new changes, and usually introduce bugs. Only optimize when necessary. As an application developer, I agree. As a framework author, I understand that at some point you'll need to optimize, and certain decisions make it nearly impossible to do so later. Luckily, in this case, I don't think it's a real readability concern. It's a syntax problem. Was that not the one? No, there's another one. There was a really cool discussion. I'm not going to find it now. This is making me very sad. Maybe it was after my comment, one of the responses to this one. Okay. Are you optimized code for the machine or for other humans? Start with the first, get the second. One is physical law and one is social. You can't remove gravity, but you can make efforts to stop people from falling off cliffs. My concern aren't limited to machines. Some of it may be preference too. Early returns introduce a secondary way to do conditionals. In the case of React, they have additional hook rule consideration, so it isn't just like we're dealing with a simple function. They are just an extended part of the template, as all hooks need to be declared before the first return. It distributes the logic in a way that takes up more space. Some people do prefer having things more spread out, but I like decisions reflecting where they sit hierarchically. Removing duplication in the template can be good not just for performance, but for composition. The article gave an example where only the success path needed to pass the title to the layout, but the separation reduced to reduce logic. However, the opposite is often true. If the component used elsewhere, you might need to apply the same logic across 3 templates now instead of a singular space. Let's pretend there is a toggle for mobile versus desktop layouts. So missing things is just as possible with this approach, except now the logic might not be in your view. It's funny because like Marco, again, yeah, I know you guys don't think, but Marco 6 is like the exact opposite of this. You can just nest state like inside the template and WYSIWYG it as much as possible. Having seen that, this is like I love Marco's capability, maybe not always the syntax is that, but its capability is like unparalleled. This is like the exact opposite spectrum. It's like the wrong direction. Interesting perspective. I prize the other way around. Catch humans in the social net to protect them from relentless gravity. What I'm getting at is if you do things a bit differently, you can align more with the physical environment rather than fight against it. You sometimes don't need a net if falling is the way you get around. Like flying with a wingsuit in the canyon of technology. Not everyone coder knows how to wingsuit properly, but most know how to walk a bridge. It depends on your peers which code style suits you best. God, I love analogies. Right. But I actually enjoyed this conversation a bit because I think this is sometimes my biggest gripe with React. React's abstraction is just far enough from the underlying like DOM, React's mutable re-render. Underlying DOM is mutable. It's retained mode, like that sometimes if you align with what you're building on top of more, you can just get more out of it. So like we make assumptions based on like this is what people think is convenient or what this, and it's like we have to obey them. This is why it's very important when we're building frameworks, we think about developer experience on that. But on the other hand, sometimes the assumptions just aren't necessary, and you shift things a little bit and you're like, oh, actually like this best practice actually is just not important at all anymore. This is all good, and that's why the React compiler does that. Does the React compiler do that? Does it look for the duplicated JSX ranges and then like dedupes them and then brings them back into here? I hadn't actually seen that. If it does, that's definitely interesting. I wonder what thing does it consider it too separate that it can't merge it back together. Okay. Just throwing that out there. Do you have an example? Example of what? If you mean like my general statement about like aligning with the platform or not in terms of like architecturally, it's like I doubt that does actually. Yeah, I mean maybe there's a future in which they can solve that specific case, but I think the problem is like I don't know. It's just very interesting to take perspective of like the compiler will solve it all for us one day versus just being write the right thing. I don't know. In any case, the reason I thought this was interesting is because it reminded me of like, again, I'm going to be missing all the freaking Dan Abramoff quotes. This is so frustrating. All the embeds that are missing now. But it reminds me of this example. I'm just going to pull it up again. Dan showed some really convoluted logic where data is happening in multiple different places, right? And then he's like, look, if you have this crazy convoluted logic and you want to add more convoluted logic, okay, so it's all the same. He's like, okay, that's fine. And then he's like, let's add some more convoluted logic and look how hard it is. But in Solid, now it's like this and like this, and he breaks it apart, right? And then, you know, I was like, why wouldn't you just, if you just align it to the, like, and obviously there's some extra syntax here because it's Solid's functions, but if you just align it, if you took his original code, let me see here. Here. You could, this is the React version aligned. I could take all of that crazy looking logic as long as I restructured it in a way that followed the data flow instead of the control flow. And yes, I needed to duplicate some kind of check when I added the extra logic here. Like, guess what? Count bigger than 0 is in 2 locations. But the end code of saying, hey, this is something else, this is heading, this is count. These are the things I care about, right? I care about this. I derive this out and I put it in, is a billion times cleaner in the end than I don't even know what this code is doing. Like Dan was like proud of the fact that like he'd taken some really convoluted code to illustrate the point, add a bunch of like logic and shown like how much harder to do it. But like the truth is, in Solid, you just wouldn't have written the convoluted code in the first place, and you just would have written this. Like, I feel that way about this early returns thing, where people are like, the problem with this article was that the logic wasn't mutually exclusive in the first place. Switching to early returns pushed the person to make the right pattern, but they could have just made that right pattern without their early returns, right? Like, yeah, anyway. Yeah, which is gets me to they really don't think of React in terms of state, derived, and effect, which is literally their API, which is what makes it so confusing, right? Because let's go ahead a little bit here. Yeah, I mean, I guess I think in data flows always. So like I I and it's probably the same reason I don't like the early returns, because it's a control flow mechanism. This is the exact same argument. It's like data flow is a control flow, right? As it gets more complicated, I still prefer data flow over control flow. It's 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 like it's just the way I think. Maybe that's not the way everyone thinks, which is why we have such a fundamental thing. I think it's being able to know like how to get this piece of information is more valuable than the imperative logic of how you got to it. Like, oh, if this condition, then do these things or this thing. I know people think imperatively this and this and this, but the data flow is actually like the ultimate truth. And it usually, when reduced down like an equation, like with math, it can be more optimal. So it's like a win for clarity and a win for performance. Where was I going? Met dev. That was cool. Okay. Types. This is an interesting question. But I actually, if you have I'm not too worried about that. Let's just finish to the last thing. Theo posted this thing, which is funny because it's just a view. Dan's argument is that you can't do control flow in Solid without verbose syntax. That's probably fair. But then, or unless you just like jam it in and create memo, but then like you don't want to do it that way. So, Solid doesn't want control flow though, really, anyways. So it's, yeah, I don't know. Like, it's one of those situations where I'm like not even remotely convinced at all. Like it's probably true, but it's just like every time there's an example, it's just like, yeah, I don't know. I think so. Well, I mean, if you watch with my stream, I actually think ruins are not great because I was thinking about that because we actually have this, right? If you've ever seen the solid labels thing, right? Solid labels, we've had it for like 3 years now. It's basically, it's ruins, right? Effect, signal, blah, blah, right? The problem, besides the teaching element of it, which is saying, like, I was convinced, swayed at NextConf towards it because I was like, oh, it wouldn't be hard. We literally already have this capability. But I forgot that I did a whole stream on revisiting reactive script where essentially I concluded that the API here, or at least from my perspective, it's fine if Svelte likes it or whatnot, isn't just like a preference dislike, but actually like gets in the way. Like I'm actually like I it's kind of awkward that like I was like sold on him, like who cares, I can just give it to him, but I actually think it's probably bad that people would use this API. Like it wouldn't, like, sure they could, but ultimately it's actually like I wasn't prepared to talk about this one. I probably should talk about this again, but I actually did a whole stream on it, so I feel like it's one of those examples where I kind of like forgot that I'd already like went really in depth, and I concluded that it was like which one was it? Revisiting solid script reactive compilation. This stream is probably yeah. There was yeah. I can't remember what the conclusion was at this moment, but I remember like it came back and we were talking about it. And I actually had a discussion with the core team about this. Like, well, why not? We could just release it. And then I was like, actually, maybe I'll open this off screen so I can actually see this. I think if I look really quickly, I can find what I was looking for. Give me 2 seconds. Sorry, people. Oh, damn it. I didn't actually write it down. I just said the exact same thing I just said. Yeah, basically, I have reasons that I don't think ruins are the direction that I'd want to go with solid from a technical aspect. They actually get in the way. I can talk about it again, but I think I covered it pretty good in the stream. No, like I think it's a bit covered in this stream, but I actually think that like the part of the syntax they compile away actually is missing. Like I want ruins, but then I still want the setter function. Like basically they can't solve the immutable read-write segregation problem in a way that's satisfactory, especially for deep nested reactivity, which we covered mostly in the store and in this stream. So like giving people a syntax that's not expandable to the full capability of Solid is actually kind of backwards. And so one of the other benefits would be so you can easily combine mutable and immutable reactivity, which I'm now coming to realize or think is actually a really bad idea. So like it's not just like, I actually think it actually doesn't give the same capabilities. It actually gets in the way. Yeah. You're like there's it's interesting. I think in an immutable world, I might want ruins, but in a mutable world, I think it's not where I want to be, and not just for DXs and people can pick up this. I actually think it actually gets in the way. I mentioned earlier from a compiler standpoint that like the one thing can't do is like matches the mutable reactivity, and yeah, I mean there might be a ways around it, but yeah. Okay. Let's go back here. Anyways, Theo showed this thing Vine for its view with HTML template language, um, and it with component function stuff. And he's like, "This looks so good, right?" Now it's just funny React. And Theo goes, "Kinda. It's more similar to Solid, but interrupts with traditional view files." Yeah. So if you don't like SFCs, so then I looked at the post engagement here, and it's like, Angular does it. That makes sense. Yeah, blah, blah, blah. Why does everything have to be dramatic? Where is it? Because the view ecosystem's underrated. That's fair. Chest pain, anytime I see something that's not JSX, that's fine. Dev Reacts, blah, blah, blah. There's something I saw. Oh, it's funny. These guys will do anything but write React. Bro, they invented React. Something React. Yeah, basically, I've just kept on seeing these comments and quotes talking about React here. And I was just like, what? Why is everything React, right? I was also on the Svelte Discord earlier, and I'm noticing these people like complaining about the ruined syntax, and it doesn't take long to. I mean, it's fine. I don't need to pull up the Reddit. So not Discord. I was on the Reddit. I don't need to pull up Reddit right now to know what I mean. But just people going on and on about how Svelte is React and all this stuff, and it's just like I yeah, I just don't do. I haven't decided if people are trolls or if they really believe that Svelte 5 or the view composition API is like these frameworks' attempts at copying React. You don't need to pull up Reddit, period. But like basically it led to this comment here, which is syntax in JS frameworks is overrated. Is anyone actually surprised that the same people who complain about Svelte ruins being too much like React now that they are migrating their apps or realize how much cleaner it is? Ruins are never about React. Yeah. I just it's we've talked about this ad nauseum, but like Evan showed that cool thing where he basically exported Solid's signal API using view signals as a, ruins. I just showed labels, which is basically ruins, 3 years ago. The change, the interop from a syntax level here, even with React itself, is so trivial. But React behavior, the reason it's felt didn't come out a year ago when they showed the ruins the first time is because the behavior is a thing that actually matters. The semantics, the meaning of these statements. There's a difference between there's a huge difference between hooks and signals. They do not run at all the same way. And but people see hooks or they see function, and it's like, oh, it's React, and it's like, no, it's actually nothing like React. And I understand this is largely because what people get out of these tools, they don't understand them in the same way as framework authors. But like hearing about syntax endlessly when it's literally the thing that like if you don't like Solid's functions, wrapping them in dot value like view style, I think I did it in the code sandbox, took me 10 minutes. Like as an author or like a maintainer, you don't want to necessarily offer like 10 billion different syntaxes. I mean, you could. I think Vue was looking at that at one point. But like the problem is you divide everyone, like you can't make, like there's no consolidated way of approaching it. But there's nothing that stops people within their own projects to make these kind of decisions. So it's like the funniest thing is now with this felt kind of backlash, and I guess we can see this better on Blue Sky, although I don't think I'm logged in right now, because I posted the exact same thing kind of as an experiment. Let's see here. Which post is more popular? I have not looked at my notifications. Let's look at my profile. Okay, Twitter still wins. But I got to talk to Rich. Basically, the idea here is that React, they're still reeling from this whole thing, right? Which was dumb to begin with. I have whole conference talks about this. Literally, what people should be looking at is like the expression count. Like this stuff is wrappers. You're missing the script tag here. So the script tag here would be the same as the function example. But essentially, this is one line, this is one line. They're identical. Oh, you have to typing a few extra characters doesn't actually matter at all. So like, I guess the problem is when people see stuff like this versus this, it's like, oh wow, the world's over. And it's like, maybe Svelte deserves this because they're the ones who made a big deal about this versus this in the first place. But it's also like, this is not like when you consider the clarity, the expressiveness of intent that can be added here versus typing 5 less characters or whatever it is, it's kind of it's insane that this is even a topic to me. And like it's just the thing, we've been so spoiled down the DX train that like this is where we sit now. Like, you know, like I know I'm gonna sound like an old guy, but like 15 years ago, didn't have such good tooling and capability that like no one's gonna be. I don't know. I guess we had CoffeeScript, and CoffeeScript let you type less, so fair enough. You know, people have always wanted that kind of thing. But it's like the interesting part about CoffeeScript to me wasn't the space syntax; it was the fact that it had like arrow functions with bindings and like um, classes, if that was what you were into, or you know, like destructuring. Like it had a whole bunch of stuff that came in ES5. It wasn't because you got the type less. There's always going to be a tool that lets you type less. It's called Marco. But like, is that really like what this is about? People will die for syntax. uh, yes, it was most people didn't want JS. Hey Jay, yeah. No, I am on a Mac OS machine. Sorry, just catching up with chat here. Most people look at things look. Yeah, I know. It's just we're at a point now where the looks are so superficial that you literally can be looking at the complete opposite thing and they look identical. That like I can say stuff like ruins are nothing like React. Svelte 3 was just like React and confuse the hell out of people on a daily basis. And they literally don't think about how any of it works. Yeah, I mean, I mean, I love this about JavaScript and about the web, is that you can just pick it up and not worry about this stuff and just build something. But yeah, I mean, maybe I'm in the wrong field. I literally only care about how things work. What am I saying? Did I say ruins? Ruins? I don't know. You won't believe the reason they tell us so they type fewer characters. Compilers. I didn't even Jay. I didn't even realize how does commenting even work on on X. Like, are they? Is it enabled? I didn't even realize there's a chat in here. Oh, there is. You're the first one. Well, that's good. I'm glad chat is enabled. I don't know. It's the syntax thing is just. It's something I'm gonna have to live with. I've known this for years that this is what people look at. It's just like there are mechanical implications of syntax and back and forth. They aren't completely separate. They are related. There are importance elements of it, but like the number of characters you type is probably not an important element of it. So yeah, I don't know. I'm kind of at the end here. I'm gonna wrap up here in a minute, but I don't know. Maybe I should pull up the Reddit. Maybe this is the last thing that I want to look at here. Let's see if I can go R svelte. Look at my notifications. Here, I saw this thing, and maybe this is where I'm gonna go. With frameworks like homogenizing, I believe Svelte has no future. God, gotta love Reddit. Svelte is my favorite framework, but I worry about choosing it as it could become obsolete. Svelte has compiler, signal-based reactivity, simple HTML-like formatting. Here's the thing: Solid has a compiler, Vue is working on Vapor, Signal is being docked by everyone, Vue's ref is similar, moving towards being complete signals. Weren't they always complete signals? What the... Oh. Yeah, I mean, I can understand the sting from Evan's standpoint. You know, he's like, they're called observables and refs and Vue. Signals came before the composition API, like by several years, but I get what he's saying. Vue has been doing this kind of reactivity under the hood for even longer. So, okay, let's key here. Yes, state derived effect. Yes. Problem is that when Vue eventually sees a compiler, does Svelte have to offer? And when Vue has a compiler done, how can they do something better with something with funding? Svelte looks different flavor of Vue, except Vue has jobs and libraries and aren't abandoned where. It's funny. I'm sure, like, we actually get this question, I think, on Solid Discord or Reddit as well. Are people worried that after 7 years yeah, Svelte, actually, we should wish Svelte happy birthday. Just a second, GitHub. Svelte is almost to the day, I think, SvelteJS, maybe, is almost to the day 8 years old. I know there's probably a quicker way of figuring this out, but what I like to do is go to, what is it? Commits usually. Like, where is it? No, not the specific commit. I need the commit history. Why am I not seeing it right now? I mean, I could look back on releases. Why am I not seeing it right now? I'm just blind. I'm just so blind right now. Why am I not seeing it? Commits. The clock icon. Yeah, it's because I'm like blown up. I think that's the problem. I'm like so blown up here. There it is. All right. How many commits does Svelte have roughly? Too far. This is my hacky way of over 9,000. Yes, over 9,000. Too far. 95. November 15th, 2016. Next Friday will be Svelte's 8th birthday. Okay, so are we worried that after 8 years, Svelte's finally just gonna drop off? It's so funny, like when these companies picked up React when it was like a year old, like what were they worried about? So yeah, I mean, I don't even know what I want to say about this. It's just, it's so. I'm starting to wonder if people just want to give up. Like just like if it's been so long that they're just like it's kind of crazy that you've been able to use Svelte for years and years and years and years, and people still treat it like this new thing. And I guess the problem is there's an expectation of adoption to a certain degree that I guess frameworks now just don't hit because of how saturated it is, right? Svelte's been doing pretty well for itself, but compared to Vue or Angular, it's just a splash, right? Solid's like a splash of Svelte, so to speak. So like and quick, interesting is even a splash of Solid. Like basically, it's completely inverse based on the year that the framework was created. But like, there's still an incredible amount of value in this exploration, So like, I don't know. Hopefully people can kind of see past this. But I just it just more and more. It's just I bet you if I look here, I'll see more comments about React. Yeah, no, it's fine. It's just I don't know. Maybe it's just that the arguments and stuff get old. Every year, you check in and see where things are at. It's just it's an interesting question. Are we supposed to just like is Evan, Rich, and myself supposed to just like throw in the towel and just say like let's make the one super framework now we maybe mostly agree on a lot of stuff, or is that how you beat React, or do you have multiple options? Like, is this a problem people are feeling now that things are consolidating, that like they want to pick a horse and they can't make a decision, so they're actually being a little bit like trying to goad in that direction? It's interesting because each maybe they're right. Like each framework has had its own identity previously, and um, yeah, I mean, I never was really concerned with it initially because I was just building what I was building, and in terms of signals. But now like everybody has signals. I'm continuing to push in the directions looking at the reactivity stuff. You know, Svelte's very concerned with syntax, for example. So like, they spend a lot of time like the one tempting thing about doing something like ruins was actually to copy Svelte's ruins identically, because like if I want, I trust that they've considered syntax probably more than I have. So like, and Vue's always thought about onboarding, like how step up. I mean, Svelte has too. They both Vue and Svelte actually invest a lot of time in docs and training and tutorials to get the front of the funnel, which is great because it really helps with adoption. But and compared to React, just starting that far behind. So it's like, I don't know. Like, maybe is that what where we're at? Is that what people are looking for? Right? Like, these things are still developing. It'd be interesting to be able to share everything. Yeah, I mean, this is interesting. It's hard though, because the signal scheduling is different. The interesting part is one thing that Svelte, Vue, and Solid all have in common is our components are like we have DOM elements. Like when I try to interop with React, it's like React doesn't know what a DOM element is. But like these all have DOM elements. But on the flip side, I don't even think this is the problem. Do you know what I mean? Like people go, oh, the ecosystem stuff. It's not the ecosystem of libraries, I don't think. Because I don't know. I like there seems to be whenever someone's like, oh, why isn't there this in Solid? I go looking at like, oh, there is actually. Like this hasn't actually been a problem. It's the ecosystem in terms of like hiring, jobs, training, education. Like it's the there's a people aspect that goes beyond the libraries. Yeah, like it's not that you can't find these libraries. Like, oh, there's maybe more maintainers at a React library. There's more choices, but you have like I keep every week someone's like, I wish I could use ShadCN in Solid. It's like yeah, we have like three of them. Yeah, I mean, it's like my web component argument. It's there's just so many other factors. I I don't know. I content creators, yeah, but like it's the like everybody standing on the cliff scenario. I'll jump if you jump. Like it's that scenario. No, no, sorry, I didn't get to that. Honestly, that's a whole other topic, and I'm really actually trying to wrap up. I'm sorry, I keep on stringing on this point, but I actually have to wrap it up. I'm getting close to the 6 hour mark. In terms of yeah, sorry, let me see where the thoughts on back pressure. So let's see frame rate, back pressure. But all this, yeah, yeah, I don't, I, it's an area that I haven't been focusing or looking at all really. My most recent exploration has been largely around um, granularity projecting throughout the reactive graph. So like trying to find ways to reduce the amount of diffing needing, but keeping things granular. Yeah. Anyway, so yeah. Yeah, so I haven't actually been keeping up with Jaguar. Yeah, it's all good. Um, anyway, I'm gonna go. Thank you all for joining me, and yeah, we'll catch you all soon again, if not next week. Probably actually wait for Thanksgiving, so we'll see. Hopefully next week. We'll see. I had my first. I mean, it's always this stuff. All right. Catch you all later.